Here we go. Ugh. Okay. So I made a couple changes over the weekend, and it's best that I show you guys. So we have this right now. So as long as I can get the center of mass, which I can, if I go like this, create empty object. There's my empty game object. Right now we get this, and we put this exactly where we want it. But I think what we want is we want it here. And then if we come into here, I'm going to actually change this by removing this one. Remove. And then we're going to adjust this one here. Yeah. Right about there. Bring that in like so. Yeah, there we go. And then when we hit play, that up, that gives us our easier center of mass. Right. I can talk here unless you ain't looking at chat. I am looking at chat. It just took me a second to look at chat. Hey guys. You wanna jump on a voice call? I wasn't expecting somebody so quickly. Usually not that long, dude. Wait, what? I can't. I can't mate. I'm in the office. Oh, okay. Yeah. But we'll lurk here. Okay, sounds good. Did you see the images I sent you last night? I mustered all of my absolutely horrid art skills. Got a phone notification. Don't open them at work. Dude, hey, I worked. I actually tried really hard. So I worked really hard on that. Um, as I mustered as much art skill as I could for it, and I tried. I tried. We can chat about it more at some point, but only thing I'm thinking that my job is to feedback on the game and handle the art and visuals. Oh yeah, I thought like I so like the idea that I had for the combat system, I figured that could be an interesting way. I don't think I've seen something quite like that, although that first game I sent you that my friends gave me, apparently it has a kind of like a playable cutscene system. As do with everything else. Oh, okay. Yeah, I still don't know what I'd want to do for like the overworld gameplay or anything like that, but like the cutscene gameplay, I think we could do something interesting with that. Around like it's very inspired by Pokemon, but has nothing to do with real world battling. And I was thinking about it, right? Like depending on how we do certain parts of it, we could reuse a lot of assets to because like effectively you'd need like potentially like a hand and or two hands and some other parts. Yeah. Anyways. Oh man. So good. I finally got my truck to stop bouncing, and that's kind of been the highlight of my day. Or I should say the highlight of my week. And the truck doesn't bounce anymore. Actually, maybe this needs to be there. Yeah. Okay, so look, it's not bouncing. It's beautiful. It's not going like this. The spring was intense. You wanna? I'll plop the old one down. We're gonna see two different versions of this truck. One of them is substantially better than the other. Yeah, I forgot that's not gonna work anymore. Physics objects. Anyways, let's get the center of mass updated so it's not leaning forward like that. Okay, so what we're gonna do is I'm gonna zoom out so we can see the truck. This is kind of where I want my center of mass to be, I think. We're gonna copy that. Then we're gonna go to is it here, advanced. Yeah, here we go. And then we just want the oh, it's supposed to be 0 center of mass. This one's supposed to be the one that I'm supposed to be changing. Position copy. I don't know if it's gonna let me paste that in. It's not. Um, fun. Okay. So great. Where's my book? Okay, so I go to here. No, sorry, I go to here and I'm looking at 0, 0.63, and 0.36. I was trying to get it so I could actually like visualize the actual center of mass point specifically through the physics body, but I wasn't. Oh, I did the change and it was just giving me a spot here, but I wonder if that was because of a different issue. Because I'd love to actually be able to visualize it outside of what we currently have, which is just like an object that's trying to take the spot, right? Oh yeah, I forgot about that. I canceled that subscription. No more Copilot as of today. Um, yeah, so I did it here, I think, right? On on Draw Gizmo, right? Right, and then we would want a temp color, so color uh, color cache or Gizmo color cache. gizmos.color. Gizmos.draw wire sphere. And this takes in a center, which is the M center of mass, which is just a float 3. And then we do the radius of 0.5f, right? But we want to draw this as a relative location, right? So I want to get world location of object. As it would be unity get world location of game object. Transform position of game object script. The script is attached to. Let's take a look at what we actually have already. Mono behavior. I think this has a transform. Oh, maybe it doesn't. This might be entirely baked. No, this is a mono behavior. It's a physics authoring mono behavior. New center of mass. New rigid transform. M orientation. World index. Kismet mass. Linear dampening. Oh. Wait, what? Would it just be object then? Or would it be this dot transform? Oh, it's just transform. Dot position. Plus the M center of mass. There we go. Is the issue that this is a float and this is a vector, right? Yeah. How do I convert a float to a float 3 to a vector? I guess it would just be vector 3. Or sorry. Unity convert float 3 to vector 3. That's not what I asked for. So this would be float 3 dot implicit. Converts a vector 3 to a float 3, converts a float 3 to a vector 3. This would be float 3 dot. Was it? No. Give me a second here. Yeah, no, this should just be float 3 dot implicit, right? Oh, you know what? This just might be this. Oh, sorry. This is vector 3. Interesting. vector3 dot x dot y dot z. Does this require a new? Maybe. No. Oh wait. It's because it's like these, right? So weird. All right. What I could also do. Give me a second here. I'm just thinking. Could do the entire offset the way that like through this we could do m center of mass dot x equals transform dot position dot x. Yeah, I think I'm just gonna do it this way. Dot y equals transform dot position dot y m center of mass dot z. This is not the way you should do it if you care about performance. Just FYI. Sup? How are things, my friend? You good? That's good. Oh, this wants a vector3 maybe? Wait. Oh, yeah, it does want a vector3. Oh, it's because I didn't have the that. They're good. Good is good. I'm gonna see if I can get this. Oh, I forgot to update the gizmo color back. I'm gonna see if I can get this to show up correctly. I have no more Copilot, so this is entirely got to be coded straight from just me now. No more of the good stuff. Ah, man, the center of mass still doesn't work. Oh wait, no, wait, that's not what I wanted. Wait. Is that right? I feel like no. The center of mass still doesn't want to like display properly. Oh wait, no, it's because it's 0. That's perfect. There we go. Then what's this one? And delete that one. Oh. Right, because everything that has a physics body has a center of mass now. And all of them are at 0, 0, 0. Off ran out of the free Copilot. No, I canceled my subscription. When I was working, we were encouraged to use it because it does boilerplate code really well. So we used it for that. I think this center of mass is wrong. Something tells me it's that. Yeah, I was right. It's in the wrong spot still. Damn it. I don't understand what the offset here is. So I'm just gonna leave it out for now. It's just more confusion than it's worth. This does tend to happen for some reason. Hacking TV. Hello. Oh, the weirdness that is Unity. Null reference. All right, I'm gonna do that because something weird's going on. Remember you sent me the voice assistant about years ago? I had a feeling it might be you. Did you ever get it back? It got lost in the mail. Yeah. Yeah, no, I never got it back. Yeah, I take it never ended up to you either. How have things been? Well, yeah. No, I never got it back. I still have some though. I still have a bunch of them. How have you been? It's been ages, dude. I want to say it was this way that I wanted to go. Good man. You doing games now? A little bit, yeah. Yeah. Um doing the whole trying out the whole game devs thing. I did a like diploma thing in 3D modeling, and I kind of decided that I wanted to give this a shot. I'm not gonna lie, I'm a little bored of web dev. It's a lot of like web dev's just like a lot of the same thing over and over again. I've considered it, but it doesn't have what I need for this game. I was using Unreal for a little bit, but the Unreal system is unfortunately um, too early days. Yeah, they haven't been working on it super well, so I did that little stint with Jamie and his crew for their Notify. I don't know if you were around for that. I don't think you were, because but man, programming finally became the thing that we wanted it to be, right? What have you been up to though? Oh, I joined the Notify team for a little bit, and that didn't end up going well, unfortunately. But Jamie definitely brought a lot of eyeballs into the programming area of Twitch, and then there's like Pirate Software and the Primogen. I think the Primogen was like just getting started when you were like just around the time. It was so dead back then. I know, right? There's so many more people here now. It's just like crazy. There we go. Look at that. That looks about right. It's it's actually standing now instead of bouncing. The thing bounces so much. I've got video of it bouncing all over the fucking place. Oh yeah, back in the day when I didn't use a camera, because I was in the bedroom, and I didn't want to have a camera on because my girlfriend was always there, or like had to be involved in some way effectively. So I never had a camera on, but now I got a green screen. Do you remember Don the developer? Give me one sec. I'll be right back. Oh, okay. He might have been just after your time. Oof. All right, I'm back. Yeah, I was gonna say Don's still around. Could Phobia stop streaming though? Staghouse is married with children now. I don't remember. I don't know if you remember Staghouse, but he's all married with kids now. Um, C Sharp Fritz doesn't stream super often anymore. I don't think. Clarkio streams periodically. He did Python for a little bit. I was kind of surprised because he was hardcore into JavaScript. Irish John is still streaming. Pirate Software got bigger, although he was barely on anybody's radar back then. Yeah, Pirate's huge. His game blew up. That's kind of cool. Is the car moving or is it just me? Oh, it's still moving backwards. My center of mass is still off. Damn it. Do, do, do. Did I make it? No, but I worked on it. It's not out though. LAPD? No, it's that's a friend's company. Yeah, this is my friend. This is one of my friend's companies. I I've rebuilt his multiplayer and a lot of his gameplay systems, but I haven't worked on it in like a year. Yeah. He hasn't like this is his only released game so far is the beast mode, which is arguably it's an interesting game. I don't think anybody's ever streamed it on Twitch. We could be the first. I actually own I actually do own a copy. I actually own two copies of LAPD 2195. I might be working on a game soon, like another game soon as well. But this time with a friend of mine. um, who is in. Oh, I don't have it installed. Damn, but I have LAPD. 21.95. There we go. Install. I don't think that you. I think if I click install, it doesn't actually install anything. Because I don't think an executable has ever actually been uploaded for this game. I do have the most updated version of it though on my PC. Yeah, let's see. Do. Yeah, let's see. I'll show you my current game. Yeah, this is do. Where is it? I think it's this one is the most up to date version of the game. But like it's effectively I did all the networking for the network programming for like movement, uh the lobby system for Steam, the firing and all of that. And I worked all of that out. And I'll have more gameplay stuff to do eventually. It's just he's been really busy and he's working on the map. And some personal stuff is being slowing him down a little bit. So, did you use Elixir for LAPD? No, but I did use this. I worked at a Toronto company doing Elixir for a little bit. No, LAPD is entirely C++. The Score. I worked at the Score for like a year and a half. I think I think that they ended up launching a sports book in uh in Ontario. By the way, the Score, great company to work for. They're hardcore, but their code base is fucking clean. It's so clean. Their code base is, oh my god, it's so clean. It's the cleanest code I've ever seen. Let's see. If I go builds, I'll show you what the current version of Truckcoon, the game that I'm currently working on, looks like. So I believe this is the latest exe. Um, Although I have a version of this with better ragdoll physics. Yeah, it's a little it's a little on the slow side right now. Let's see. Yeah. I was at the Score when they got bought out by Penn National. Yeah. Yeah, yeah. I was Vancouver based. Let's see. We'll do the I think it's city map. What is missing from Godot? You have in Unity? So Godot has, I believe they've got shader issues. Like the shader system in Godot, I think is supposed to be kind of subpar. But um, is this map completely dead now? Oh no, it's not. Okay. Whew. So the shader system is still needs a lot of work, but they don't have an ECS, so an entity component system, and I need an entity component system for my game. And I don't want to shim one in, right? Because it's not gonna play like you've got to effectively like shim it in and like get physics working and everything like that. And this is what the entity component system's for. So I'm working right now on getting Unity to the same point I'm at with Unreal. So right now you have these girls, these pink-haired girls in the skirts. You run them over their targets, and then the other girls you run them over, and they're pedestrians. These girls here, these ones, the one that there's a lot of, you'll get negative points of some kind. Like there'll be a penalty for running them over, because you're only supposed to be targeting these girls in black skirts. But I've got custom meshes for them coming soon. These are just placeholders. Whee! But yeah, it's almost exclusively just that Godot or Godot or whatever. They don't have a entity component system. And then the one in I'm stuck in an fucking ad. 7, 6, 5, 4, 3, 2, 1. And I think we're back. Yeah, so so Godot or Godot or whatever, however it's supposed to be pronounced, I can never remember. It doesn't have a entity component system. And then the one for Unreal, for Unreal Engine, right? The base of it is beta, which means that it's mostly complete, but it's not production ready. And then the mass crowd system that I've got to use and the AI system and the gameplay system are all experimental. So effectively, if you want to use mass entity, you've got to be okay with it being beta, which is unproduction ready. But also you've got to effectively write a lot of like low level code for this stuff in order to get it really working, because these are like buggy fucking messes, right? And it was driving me batty. And then I come over to here and we go to their package manager and we do and there's this called Dots. But theirs is production ready. I think theirs is production ready as of Unity 6 or like something like that. Like it's pretty new to production ready, right? But it's missing a bunch of things, which has kind of been my biggest pain point with it. It's missing. It doesn't have. Sorry, let me think for a second here. It doesn't have anything but physics effectively. So like the vehicle system, you have to build that from the ground up. And vehicle systems for video games are kind of interesting because wheels don't actually exist. right? These wheels here are just graphics. There's no collider on them, right? So the wheels don't actually collide with anything. You just have a point in space that is the effectively like the axle position, and then you have a spring that's attached to the effectively a point that is your suspension. And then you move the axle position to move the tire, right? And or you move the tire itself up and down to figure out exactly like where you want the tire to be, and you effectively you cast a ray straight down to figure out where the tire is supposed to be, right? And that gives you that. But these wheels have no colliders, so this truck effectively has nothing underneath it. So you could slide something underneath there, it's never going to hit anything. The tires will act like they're hitting something, but there's no resistance there because the tire doesn't have a collision. So it's kind of cool that way. It's kind of interesting. We finally we I finally got a vehicle system working. Um, to be fair, to get the vehicle system working, I went and I grabbed the uh, one of the YouTube viewers suggested a system, the ECS network racing game template, and so I grabbed that, and I managed to strip out all the multiplayer stuff and get that kind of in here, but I don't have a controller hooked up to it, so you can't actually move the vehicle. But it sits, and that's the important thing. And now I just gotta hope that I can get the rest of it working. Right. So Hacking TV, are you gonna come back to streaming or still checked out on that one? Too much commitment? That's fair. I figured it was probably something like that. Like life changes, right? Oh, that's fair. Are you doing contracting now? Hey Hagel. Hey Hagel, how's that tablet working for you? Basically, yeah. Nice. Contracting's got to be treating you pretty well. You were in finance back when you were streaming, right? Yeah, that's what it was. I thought it was a bank. Still trying to calibrate it. It's still causing problems. Oof. Sorry to hear, man. I was really hoping that would help. Has it helped a little bit at least? It was what delay, right? Like you had like a weird delay, if I'm not mistaken, right? It has two things that happen that I can't replicate it. Is it one of them's delay, right? Which I think is weird because like I never had any problems with it until I switched to 4K. Right? When I switched off of 1080, I had like it wouldn't function properly. But that's also because like I was pumping a 4K signal into it. So I figure as long as you're pumping a 1080p signal into it, you should be fine. Oh, interesting. I think I did experience the jumping in a direction when I was sculpting with it periodically, but I was never able to replicate it, and it would happen completely randomly, and it could have also just been ZBrush doing that. But yeah, tracking just stops. It's so weird. That one I don't think I've ever encountered where it just like stops tracking. Oh, Hacking TV, Hagel, Hacking TV. Hacking TV is one of the OG um, program streamers, programming streamers from back in the day when I first started streaming. Um, and and then Hagel is a graphics artist that's doing game development periodically. Yeah, when I started streaming, short as some like within my first year of sorry, actually, what's the best way to word this? Hacking TV was like the biggest one of the biggest programming streamers around the time when I was first starting streaming. Yeah, but that was the biggest. The only person that was above you was that one guy who was like getting like 200. That was about it, right? There was that one guy though. That one guy. I can never remember his name. He still streams, I think, but he doesn't stream super often anymore. Yeah, there was one guy that had a few hundred, and now it's like the top row is people programming with a few hundred people. I thought back in the day when like there was like the three or four of us and we were like the top people in programming all the time. With like my average viewership of like 15 people. To be fair, 15 people is still a lot. I'm happy to see you still sticking with it. I sometimes wish I did too. Yeah, you probably would have like with the way things were going with you, if you kept with it, you probably would have made it into the hundreds, right? It does. That's like my entire reason for doing it, though. You just can't be consistent enough to keep streaming. That's fair. Yeah. But yeah, Hacking TV. Like if you stayed with it, you probably would have been one of the really big ones. I think you had like you had the right mix of like interactiveness in your streams and like your energy people really attached to. So I think if you came back, if you ever end up finding the time and coming back, I think you'll do pretty well. You know, I was jealous. I was never able to pull that off. But whatever. You know, you had the more entertaining stream. Let's be honest. Hello, Sald. Was Sald? Yeah, Sald. I was just jumping up and clapping my feet to together, dude. Just being silly. Yeah. Yeah, but like you had like projects that people like engaged with. My projects were like nobody really cared about. I did so many I almost fainted. God damn it. The bottles of Sailor Jerry too. Yeah, I was trying to get into that. I was always missing the mark. Cuz I think when I first started streaming on Twitch, I wanted to make like a Discord clone but make it open source. And then the next thing that I did was just like Twitch bots. Like I was just making Twitch bots. But like they were really rudimentary Twitch bots and like it was weird projects like let's make a Twitch bot using no third-party libraries, like just straight Python standard libraries and stuff like that. So yeah, I was kind of disappointed that it got fucking lost in the mail and we never did figure out how to get it back to you. Does anybody use Revolt? Maybe. I don't know. It was probably pre-Revolt. I never got it off the ground because like my JavaScript was never at a point where I could pull off the chat. Like I could pull off the chat on the back end, but like the front end for the chat, I was always struggling with. And now I could probably figure it out, but like I just don't really care enough. I think that like the there's really not like a way to do that kind of stuff anymore. It's just too expensive at this to get unlimited soundboards. Nice. And have to build my Discord bot in the and trigger from an interface. Let's take a look. Oh, nice. It's all in Elixir. A bot taken with the following permissions and read message history, view channel, connect, speak. I really should take a look at this. This is cool. I was always wondering how they did like how they pumped music into Discord through a bot, and I never really got around to looking into it, but I should probably do that at some point. This is cool, dude. Friends VC because we use soundboards a lot. You only get like 16 slots unless you upgrade the server and have Nitro and a bunch of other crap. Yeah, that sounds about right. They're trying to get money out of like they're trying to make the game the service profitable, and they're on a struggle bus with that one. Wait, when did you start Elixir, dude? And what do you think? What how do you feel about Elixir? I miss Elixir. I haven't programmed in Elixir in too long. Well, a while ago, I need an excuse to make a project. Phoenix was live views is great, but the community is so small, it's worrying. Yeah, there's really not a lot in the Elixir world. I'm a JS fanboy, and end up reaching for uh, Savalt, Savalt. I can't remember how to pronounce that one or something. If I worry about maintainability, that's fair. It's crazy. The cleanest code I've ever worked on professionally is an Elixir code base. It's a Phoenix code base, and that's at the score. But I think that's mostly that has nothing. I think that has very little to do with Elixir so much as actually it probably has a little bit to do with Elixir, but like also the regulations behind sports betting in the States is absolutely insane, and I think that definitely pushed them to have like extra clean code. Yeah, it's so true. It's so true. You'll fight the language and compiler if you're doing things wrong. It's so true. There's Elixir is an interesting beast. Yeah, JS lets you just do whatever. I find that I gravitate towards like strongly opinionated systems. So like I like Django over like Flask for Python because Django's strongly opinionated, and I prefer like Unreal over Unity. And Unreal is very strongly opinionated. But Unreal definitely has its pain points. So this is cool though. I didn't know about this. Is this like a decentralized system too? I am gonna do a star. Revolt sounds interesting. I don't know if I'll set one up, but it does sound interesting. Let's see. What was I gonna do? Right. Unity dots controller. Getting started. Third person. Here we go. Yeah, like Express is just like to program your stuff. It's like I'm doing laundry, but I'll leave this up. Sounds good. I think Gaz also has me pulled up right now, but he's on. I think he's on the YouTube side. Yeah, Gaz is on the YouTube side. Okay, so we need. Yeah, yeah. That changed like a year and a half ago. Oops, that's not how you spell YouTube. .com. So if I go to here, your channel. Yeah. Oops. No, it's live. No. Yeah, here. There we go. A year and a half. Yeah, even yeah, I'm breaking the rules because my chat will show up on both, but yeah. Yeah, if you look at the bottom, I've got like the little chat bar, and Sold here said, "Hey guys," and that will show up with the little YouTube symbol next to it. And it's why all the messages from you show up with the little Twitch logo right there. Yeah, when did they do that? When did Twitch allow multi streams? Streaming 2023. Yeah, TwitchCon 2023. They announced it. Yeah, I figured now is a good time to. I figured for that I should probably do both, and that way I can grow a YouTube community as well. Um, and at the very least, like I can get hopefully monetized on YouTube, and then I can, and hopefully I'll actually start producing YouTube videos. I've been working on one with this. If this ever opens, something weird's going on there. I don't know what's going on with DaVinci. Usually DaVinci just opens. It might take a while, but it just opens. Something's definitely not responding correctly. I was gonna show you the bouncing truck. It fucking flies. I can't do it anymore because like the physics engine is a little like physics collisions are a bit different right now. So there we go. Yeah, I've been working slowly on this little video here, but I've got some of the fun stuff here. Let's just do this. Is it gonna work? The truck. I give you the truck. Let's see. Let's hit pause. Stop. We'll come over to here and we'll put shuttle on. This... There you go. Okay, and then put shuttle on, and then we can go like this. Yeah, here we go. This is one of the ones. I've just effectively been like going through and finding like the clips from while I'm streaming. Let's do shuttle. Here, this will. So some of these truck bounces got really crazy. I think this one was pretty good. Oh wait, no, this isn't one of the good ones. This one maybe? Yeah. Maybe? Mm. Some of them start picking up speed and then the truck just goes flying. In the most delightful ways, of course. Yeah, this is one of the ones that I was kind of thinking of here. I think I play with some of the numbers on one of these, and when I play with the numbers, the truck just goes boom. Mhm. But yeah. Did you? Anyway, so we went from like this wheels bouncing, truck bouncing to now we've got this bad boy here where it actually just kind of sits there. I don't think it's moving. No, it's moving ever so slightly forward. Once I do player input, I think it will change. To do open we did that. Create a sub scene if you haven't already. Navigate to the sample character controller version, standard character, third person prefab folder. Drag the character, third person character, third person player, and orbit camera prefab into the subscene. Select the third person player game object in the inspector. That's the third person authoring, which we actually don't want attached to a third person player. We want to put that attached to the truck. So let's do that. We're going to come here, click on the truck. We're going to do third. Oops. Oh, wait. Do I not have that installed anymore? Let's do controller. I do not. I might have accidentally removed it. Fucking ads. Incoming ad. In 50 seconds. It's the one thing I hate about Twitch right now is the ads. I hate the ads so much. Okay, so we go here. Now I should be able to add to the player controller. character authoring. Attempt to duplicate Unity physics velocity bake. Oh, interesting. Wait, did that not go through? Oh, they finally did something about it. Likely ban it. Look at this. Twitch finally did something. Likely ban evader / restricted. And it doesn't actually show up. Holy shit. I don't think that's showing up for anybody, is it? This didn't show up for anybody, right? That is amazing. Can I report this person? Because I don't think there's like a report button, is there? Oh, I can report. Uh I is it a scam, or do I just log it as a bot? I'm gonna log it as a yeah. Uh Zing buying follows buying views. Here we go. Fuck. They finally did something for once in their life. Okay, let's see here. Error attempt to add duplicate component Unity physics velocity for baking third person character authoring plus baker with authoring component third person character authoring. Previous component added by baker. Physics body authoring. Driving seems to do world content scene. Wait. So it doesn't like that. Damn it. Let's edit the script though. And then we'll remove it. Okay, so I guess we might have to like actually like inject this correctly here. So where was the error? It was attempted to add duplicate component physics velocity baker. Physics velocity. Interesting. I don't see it. That doesn't mean that it's not there. Let's see, kinematic character utils, bake character, entity, get entity, transform usage flag dynamic, transform usage world space. Interesting. You can have multiple flags like that. That is really cool. Didn't know that. Let's see here. Kinematic character utilities. This, we might have to drop this, but this is under the character controller. Okay. Yeah. Authoring game object character properties. We don't need any of this because like air drag, jump, gravity, all of that is being taken care of already. Okay, so I think we can drop that and then we'll go back. Let's go back to the documentation though. See, we add this in and then we've got the third person authoring. Is this third person character authoring? It is. Okay. And then it wants. Interesting. This is asking for something that is not here. Where's the script coming from? Oh, it's this one. The private air acceleration against grounded hits. It's also not what we want. Third person player. Oh, wait. Okay. That might work. Okay, one sec. Let me do this. I think this can be cleared, and now if we come into here and we look at the, I think it's samples character controller, we can do, it's in the prefabs. Yeah, here. So what we want is we want a third person player, and we want an orbital camera. And then in here, we want to say the character is going to be this truck, and then the camera is going to be this camera. And then if we go to the camera here, I think the camera needs something. Main camera authoring. Is it that? Main entity camera authoring. That's not the right one. Main entity camera authoring. Main game object camera. New subscene. Make sure you have your scene. Make sure your scene has a camera game object that isn't in a subscene. Oh, okay. And then we go up to the main camera here. We're going to turn off the fly. And we're going to say main camera, game object. Yeah, that's all we have to do. And then we're good to go. Holy shit, it worked. The camera's... Oh, the camera's got... Oh, I didn't know that it was going to let me do that. That's cool. Okay, so now what we want to do is we want to come down to here. And we want to edit this one. Edit script. And then we have to figure out the movement. Character controller. Controlled character. Yeah, there's the camera. Understanding how the character update works. The character controller update happens in two different frames. I kind of just want to grab the... let's take a look at the prefab for the third person player. No, character, sorry. Third person character is what we want. And then we just want to take a look at the third person character authoring script. Hit scripts. And then what we're going to do is, here's the baker, right? And we're going to add this entity here. And there's our third person controller. So if we're doing that, we should be able to find usage. Actually, no, we just want to jump to it. Yeah, here. Okay, so this is the move vector. So that gives us our move. And then what about this one? Oh, that still comes back to it comes back to this, which has a bunch of data in it for like our jump and stuff like that. Hmm. But where is okay, so if I come here and I go to find usage, let's see how this is getting used. Because we want to find effectively the system it's being called in or like queried in, right? I aspect, I physics update. Third person here. This is it. On create with all character query. Kinematic character utilities base character query builder. Third person character component and third person character control. New third person character update context. Physics world singleton. Yeah. Required for update. Okay. And then we have our on update and we grab the character queries. Where is this getting used? Requires for update, and then we pass in this. Now, if I'm not mistaken, this is going to build out like extra variables that can be passed into the job, which is update job. Yeah, here. Physics update. This still might be the way to go, but I don't know if it's actually what I want. I might just not use this and I might write something myself. Yeah, this is doing a lot of extra that I don't actually care about. And do okay, let's open up the network samples, new window. This has a controller in it that we should be able to use. Car input authoring. This is it. Player authoring. No. The only issue with it is that it's all related to yeah, like it's all netcode based stuff. And that's about the only like the big pain point here, find usage. Do car input authoring. But then where is no, we need a gameplay vehicle where we're seeing how it's getting used. Component lookup car input. Because like I can grab specific controller stuff and push it in, but like we want to try and avoid doing that because system calls anything out to a system API is like a quote unquote expensive function, expensive call. We want to try and avoid that if we can. But this looks like the one that we're looking for here. So here's our car input. struct, this is an I system here. Before physics system group, that's fair because we want this to run obviously before. State complete dependencies, which our dependencies are here, required for update race. But we don't actually need a race because we're not using a race. Race, from what I remember looking at, it looks like it's part like effectively like all the information, like your countdown, your finished progress, where you are on the map and stuff like that. We don't care about that because it doesn't matter. Where was it? It's here, yeah. State complete. Schedule parallel state dependencies. Our only dependency component car input. Here's our vehicle input job. What does this look like? Has component. If car input, right there, has component value, dot value, has component reference value. Interesting. Return. So if it doesn't have it, we return. Chassis reference value. This is the vertical and horizontal, which is just this. But where are these being set? Find usage. So these have got to be being set somewhere. Wheel input system. Get component car input. Wheel input job. Do I not have this input at all? Oh, here we go. There's our horizontal. That's mobile. Oh, we're using this, which is not what we want. What is input? Input dot value horizontal. No, but what's capital input? Runtime input, which is input component data. Where's this stored? Get access. Return the value. Returns the value of the vertical access identifier by access name. That's not what I want. Get button. Get key down, mouse down. Oh, interesting. You can't use the new input system, I don't think, in dots. That might actually be a thing. Yeah, this is a legacy input system. That's what I thought. Unity dots new input system. Your approach seems good and to do. System API is a class that provides caching and utility methods for accessing data in an entity's world. It works in non-static methods in system base and non-static methods in iSystem base in iSystem that take ref system state as a parameter. Interesting. Okay. You can use it to perform the following actual actions. Uh, iterate through data, retrieve data per entity that matches a query. Yeah, which is this, right? There's our query on update. Ah, okay. That makes sense. Query building. Get a cached entity query, which you can use to schedule jobs or retrieve information about that query. Access data. Get data buffers and entity storage info. Access singletons. Find single instances of data, also known as singletons. All system API methods directly map to the system you put them in. This means calls like system API get singleton checks whether the world that contained Marsuv's Vex. Welcome. Thank you for the heart. Get singleton checks the world that's contained on the system can perform the action. System API uses stub methods, which oh shit! Thank you for the raid. Hot damn! I hope you had a good stream. What were you streaming? How was your stream? And how are the 14 people that you came with? Well, welcome everyone. It's nice to have you all here. We're going through the Unity dot system to try and figure out how to create a input system around the new input system, because the one that I found is all legacy stuff, and I really wanted to use the new input system because I prefer the calls to it. So many people, all the people. We're doing all the fun stuff here, which is like literally just trying to get this vehicle to drive forwards. The camera's a bit off at the moment, but you know, the idea is there. uh, see. To inspect your system, use an IDE that supports source generation, such as Visual Studio or Rider. And then go to definition. And that will give you, okay, one sec. APIs. Oh wait, I was up here. Yeah. Let's see here. System API uses stub methods, which means that they all directly call throw code gen exceptions. This is because System API uses the Roslyn source generators, which replace the methods with the correct lookup. This means that you can't call System API outside a supported context. That does make sense. So this illustrates why you need to mark systems as partial. That also makes sense. Iterate through data. To iterate through a collection of data in the main thread, you can use query methods such methods in both iSystem and system base. System types, it uses C sharp idiomatic for each syntax. For more information, see the documentation, which we kind of already we already kind of went through that. You effectively just build out your system, your your query. Let's go to one of these here. We can go to my bad one here, right? Is this even making a query? I don't think this is making a query anymore. Here we go. So like if we take a look at this is grabbing all entities that have an entity, which is literally every entity. And then we're querying out for anything that has the dots player and a vehicle configuration, local and local transform, physics velocity, local to world, and suspension data. And this allows us to then utilize that in these entities and these variables, right? Or these properties, our parameters, whatever, right? Down here, these arguments, we can use them inside of here to actually update context. But yeah, this is effectively like a SQL query. We're saying, hey, go out, grab any entities, dots that also have dots player and also have vehicle configuration and also have this and also have that, and then we toss them into a for loop and we just run over all of these. It's actually really kind of cool. And then ECS systems do tight packing for tight data packing, which is also kind of nice. So you iterate super fast. All right. So the entire idea here is to take the character control concepts and try and get things moving. Is effectively what we're doing. But like there's so much in this that we don't really care that much about. Determines if the character is grounded on the hit or not. By default, it call I think that's a typo. Kinematic character aspect default is grounded on hit, which checks the slope, angle, and velocity direction to determine the final result. I think we don't really need that. Project determines how the character velocity gets projected on hits based on all hits. So to do, I don't really care about that. We want character movement. You can use is grounded on hit callback if your character aspect to prevent uh grounding procedurally with code. For example, if you look, I don't like this. Input handling. This might work. Understanding fixed time step updates. ECS has a fixed fixed step simulation system group that acts as the default group where systems update at a fixed rate. On every regular update, Unity keeps track of how long it's been since the last time it ran a fixed update. Then it runs the amount of fixed updates that correspond to how many should have happened in that time. In practice, this is capped to a maximum amount of fixed updates per frame. Fixed updates happen at a fixed time step instead of a variable one. And this makes them ideal for logic that needs consistent and predictability, consistency and predictability, like physics or server games simulations. For example, if your application has a fixed step of 0.02 seconds or 50 FPS, it needs 50 fixed updates to happen every second, no matter what the frame rate is. If your application has a high frame rate, the most frames uh, and most frames take less than 0.02 seconds, then there will be lots of frames where no fixed updates happen because the amount of time since the last fixed update is less than 0.02 seconds. So we want to target 60 FPS. So we'll do the math for for the seconds for that, which is actually pretty low. I think it's like 1.1 or something like that. Like where this 2 is, it would be like a 1.1 or 111. However, if your application has a low frame rate, where some frames take up to 0.05 seconds, then multiple fixed updates will be triggered during these frames to catch up with the amount of fixed updates that should have happened in that 0.05 seconds time and the leftover time since the last update on the previous frame. Therefore, on a regular frame, you have to assume that fixed update might happen 0 times, 1 time, or many times. That's fine. Sorry. When you have a system that update at when you have systems that update at fixed time steps that can consume um, punctual input events like button presses or releases, the following issue might happen. If the frame rate is higher than fixed update, you might get multiple regular updates between two fixed updates. If your button press happened during any of the regular frames in between fixed update, that input event will never be detected by the fixed update because it was only detected as pressed for one regular frame. That actually makes sense. Where no fixed update was triggered. If the frame rate is lower than the fixed update rate, you might get multiple fixed updates between two regular updates, since the state of your button press is only updated during regular updates. Having the button press detected on one frame might lead to multiple fixed updates in a row detecting the button as pressed. Kind of okay with that though. Like fixed update still kind of sounds like what we want anyways. A frame rate that is higher than fixed update could lead to jump events not being detected by the frame rate higher than fixed update could by character physics updates. A frame rate that is lower than fixed update could lead to jump events being detected twice in a row by character physics updates. Yeah, it sounds like what we want is fixed update still. To get around this problem, when processing input events at a fixed update, you can do the following. Remember, if the input event happened at any point since the last fixed update and not just if it happened on this frame, this solves the problem of input events being lost between fixed updates at high frame rates. The input event happened at any point. Huh. I feel like that requires storing a timestamp effectively. Either reset input events at the end of each fixed update or only process input events on their first fixed update that happened since the last regular update. This solves the problem of input events being processed multiple times at low frame rates. With our system, because it's entirely physics based, I don't think we have to worry about it like at all, because all of them are going to be like held effectively. Player input handling is the standard character. In the standard character is structured in a way that solves all of these problems. The fixed input event struct handles all button presses and release events. When an input event happens in regular update, Unity calls fixed input event set tick. When querying whether or not it should process an input event in a fixed update, it calls fixed input event is set tick. The tick parameter is a counter that counts how many fixed updates happened so far. Fixed tick system updates this parameter at the end of the fixed update. Maybe you do want this performance. Your character doesn't need any physics step to function properly. So you can safely set the simulation type to none on the physics component if you don't need any physics step for physics bodies other than character. Yeah, we need that. Grounding performance. The standard character includes the following prefabs: third person, first person, and orbital camera for third person. Controlling the character. Here are the main steps for how input is converted into character movement by the standard character system. The player gathers raw inputs from input system. The player converts that raw input to a format that the character can easily work with. And writes that data to the controller component, third person character controller, first person character controller, on the character. This control component acts as a common interface for controlling the character, whether it's a human or an AI controller controlling it. Okay. The character moves with the input stored in the control component. The following is an example of how this happens in code using the third person character as an example. Third person player input system gathers input from the Unity input system every frame. It iterates on all entities with a third person player input component and writes the raw input to that component. Third person player variable step control system and third person player fixed step control system. Variable handle taking the raw input from third person player input and converting it to a format that the character can work with in the third person controller component. They do this at variable and fixed update respectively, depending on when these inputs are actually used by the character. The same is done for the camera control, third person variable control, whether writes onto the handle velocity. Oh, here we go. Character velocity control is mainly implemented in your character's aspect. This one? Yeah, here. Handle control velocity. We don't have that. Okay, so where does this go? Is nothing more than a default starting point. Feel free to customize. Okay, so if we go back to samples, character controller, let's go to the third person. This one here, update prevent ground from slope change. Sure. So this is the character aspect, the kinematic character aspect, which is not really super, like this specifically is not the most useful thing for us. But it gets the idea, right? Update initialization, update parent move. This is the one that we want. Successor context. So what is this? We've lost our spot. I think it's here. No, it was. No, concepts. This was the update. Character component. Grounding, parents, getting started. Right, here we go. Handle velocity control method. Okay, so we want this. And this is being attached to here, I think it was, right? Oops. Third person character aspect. And what is using the third person character aspect? Because I don't think it's being used here, right? Let's find out what this is. What's using this? Third person character system. Physics update. Here we go. The job. What's using the job here? This is on update. First compiled. Yeah. Context and base context. And this is a physics world with system API time. Maybe as much as I want to see some concepts here. Unity dots controller, character controller. There was one, not that guy's. Because he just, not that one. It's 3 years ago. Online FPS, it's Rivals. That's definitely not it. This is also not it. I could have swore I found one earlier today. How to use the mass entity system tutorial. Cameras in ECS. It's always kind of nice. EC Unity ECS character controller. Oh, I can't listen to that. After some interest, let's see what they've got to say here. It's really just like getting the input system into there, right? Which is really what we want. And our input system, if I remember, I feel like it's been like a year since I've worked on it, and I know that it hasn't been. So if we do the player, what we want is prefabs, and we want the old truck. We drop that in there because the old truck actually has the vehicle controller script. I don't think that's it. Yeah, it was player input. Yeah, that's what we wanted. So we do this. Then we come down here and we do player input. Right? And then we're going to get rid of this old truck here. And we're going to come down to this truck and we're going to hit play. Sweet. Yeah. Okay. And then the input module. Actually, let's get that old truck back in here so we can just borrow from it. We want to jump to that, and then we go to here, and we do. Oops. That was the input module, which is this one? No. What? No, this one. Let's go back to the old truck here. Gamepad. We don't care about that. Default map player. I think we actually can't. Does this have a... No, we don't use that and we don't use that. That's fine. Okay, sweet. All right, so that's all set up correctly now for the most part. Although, give me a sec here. Let's take a look. Because I think this is where we did our events, right? Yeah, this is where we did our events for the execution. That's cool. Okay, I remember how to do this now. I remember how this works now. Right? So if we come down here, we can add our here, and if we use the Unity events like we did before, we can add all of our stuff right here. But that's not going to make the call into into ECS. Unity ECS with Unity events. Unity events. People do use the event system in dots. Using tag components can work, but it can have some notable drawbacks. Mainly, in order to add and remove event components, you'll probably need to use entity command buffer. Those only execute on the main thread, so all system updates will temporarily stop while these components are added. That can have noticeable impact on performance depending on the situation. Yeah, we don't want to do that. There are a number of other approaches devs have taken. Here are two that don't involve tag components or sync points. Store all events of the type in a dynamic buffer that buffers the parallel pre-allocated buffer. That buffer is pre-allocated. That buffer is pre-allocated to the largest needed size. Each event producer is given an assigned index range, which they can safely write to. This allows multiple producers to write to the same dynamic buffer in separate parallel jobs. All event listener jobs would be scheduled to be dependent on all event producer jobs completing first. Clear the event buffer after all listener jobs have completed. There are a lot of solutions out there which use native collections in various ways to store events. Native array, native query, native system, or stream, sorry, are all popular. Some of these are quite advanced, like the one that's made public. ECS is thread safe and burstable from 5 versions ago. You can add commands from jobs, but it will create sync points when the entity component buffer plays back. You can use the design system group that Unity already uses to play back and safely do sync points. I see a video on sync points. I'm not sure if that's the way I want to go. Like, I might actually just use the old system, like the old input system. But like, does the old input system cause problems between switching between keyboard, mouse, and controller? Oh, that's what I was afraid of.
In this video, we're going to look at 2 ways we can handle events in Unity Dots. Events are very powerful, but as you know, Dots is all about being data-oriented, so that means we have to be smart in order to implement events which are object-oriented. Let's begin. Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-app tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so here we're going to cover several ways of handling events in Unity Dots. First of all, if you're not familiar with Dots, then check out the playlist linked in the description. I've also covered C# events in another video, so check that out. Events are...
Oh yeah, Chrono. I might be working on another game soon. But that one will be like after hours.
are excellent for helping keep your code clean and making sure that your scripts are nicely decoupled from each other.
And I
However,
can't
events
really
are normally
talk about
object-based,
it.
which makes them tricky when applied to dots, which is data-oriented and very heavy on multi-thread. Now, Unity dots is still early in development, which means the best practices aren't yet known, so that's why here I will cover two different possible ways of handling events. First, I will cover handling events using a native queue and a struct for our event type, and then for the second method, we're going to do it by creating entities and adding an event component. Then in the end, I will showcase a nice complete class I built in order to make events very easy to use, which as always you can download included in the project files. Okay, so here is the demo scene. I have my player object over here working as an entity, and when I press space, I can make a jump and pipes start being spawned. This is taken from a project I've been working on, trying to make Flappy Bird completely with dots. So if you're watching this in the future, then check the link in the description. The Flappy Bird dots project should be out within about a week. So now our test here is we want an event to be fired whenever we go through a pipe. The way that this is set up is the player never actually moves horizontally, the pipes are the only ones that are moving. Here is the game and the scene view side by side, and you can see the player is always right down the middle, right on x equals 0, and the pipes are the only ones moving. This video is made possible thanks to these awesome supporters. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. So over here is the pipe move system. It is pretty simple. All we're doing is an entities for each.
Yeah, so I might be working on a game with a buddy of mine soon, and it will be a game not for all ages and not streamable on Twitch or YouTube. So that might be happening just because they make a, and it's not because we're going to be keeping things hush hush and silent. It's just because like I would get banned super fast. We'll put it there. You're not going to be able to stream that game. There'll be a Patreon for it though. The person I'll be working on it with though is a professional animator by trade, and he does really good yeah, okay. Like I might do that. Let me write that down. They got banned on Twitch, even though it was safe art. The art I will be showing is not safe. Not even a little bit safe. The guy I'll be working with it on it with is copped a ban for safe art on Twitch as well. Now he streams on YouTube. I'll have to double check though. It's more than Booba. The game would be a very illicit game. We'll leave it there. And I won't be using dots for it. It's full on not safe for work. That works. That works for me. I'm gonna still go through their terms, their conditions though, because I want to make sure that if I'm doing it there, I'm not breaking their rules. Because there's not safe for work, which is like that, and then there's like actual like it's gonna be an H game, so you know. I don't know how they feel about that specifically. It might be Unreal, it might be Unity. It's hard to say actually. Because like Unity gives the advantage of it will run on more PCs. Right? Because like effectively the way that I look at it, right, is if we look at Unreal, right, as a base, it's like your PC has to be this tall for UE, right? Where with with Unity, it's like your PC needs to be this far, right? But when you get into like high fidelity stuff or like anything to do with like a lot of things, like a lot of uh like more advanced graphics, Unreal's like, oh, maybe you only need to have this much extra, right? And Unity's like, oh, you need to have like this much extra for the equivalent, right? So like, yeah, I would say Godot, but their 3D side still has some work needed. Yeah, there was that guy that does the shader guy, right? Um, and he's switching over to Unity, but to Godot for his stuff. But he's like, oh yeah, like I need to build this advanced tooling to get what is required out of Godot, right? I can't remember his name. I'm always blanking on his name. And there he is, Acerola. That's him. Yeah, so he did this one where he talked about it and he's like, yeah, I needed to like go in and like write my own system in order to like expose the things or make the tooling required to make the type of shaders that I'm building kind of thing. So I'm just like, yeah, maybe Godot's not the way to go. But either Unity or Unreal are both going to be capable of building this game in. I'm gonna go with whatever's gonna make my life a little easier for it, and it could be Unreal, it could be Unity. There was a video
Hello, everybody,
recently
and welcome.
that I took a look at, and it explained what I've tried to explain to people around um Unreal, right? He's been fighting back with he's had like actual fights with the Thread Interactive guy. To do it's not it's this guy, yeah, here. So this guy did a talked about it in one of his videos.
What's going on?
And this has nothing to do with Thread Interactive. It's just I just remember that he's been talking about it. But like that's effectively what he was saying is I don't like TAA. Yeah, that's fair. So like effectively what this guy's a professional Unreal developer, environment artist, right? So he knows what in I think he said that he works with AAA companies. So like he knows behind the scenes what's going on and what it takes to like performance optimize Unreal to make it work properly. Yeah. But he was saying that like a lot of the big companies that are using Unreal, they don't use Unreal. Like the same Unreal that we use. They actually they do the compile from source code, which I imagine they would, right? Like I had no I did not think that they were downloading whatever the base version of Unreal was, right? But they're effectively like they have their own repo of Unreal that they're actually actively modifying and they've ripped a lot of things out of. Um, but there's no real guides on like how to rip things out properly from Unreal. And that's how they're able to get the performance that they get, right? Because like the base Unreal that everybody gets is kind of bloated. And it's just like, oh, that makes perfect sense. Well, so like it's not so much like they rip out tools and rebuild those tools specifically. It's like, okay, so if you're building a game that's not going to use Nanite, having Nanite anywhere in the code base is going to slow down your system, right? So ripping out all the Nanite stuff will speed up your game, right? Or like if you're not using specific parts of the system, you rip them out and it gives you performance boosts, right? But as far as like how you rip things out like that is not something, yeah, you're removing all the extra bloat. But you need somebody who knows what they're doing to do that properly, or else you risk bricking things, right? So it becomes a bit of a catch 22. So like like I was saying here, right? Like your performance levels when you're hitting when like if these are both equal and your system is at least this tall, right? Then Unreal is probably going to perform better, right? But like if your performance budget is down here, then Unreal's not even an option, right? Unless you can strip out, like if you can remove this section of Unreal performance, like overhead, then Unreal will outperform Unity, right? I've had really weird conversations with people where they don't understand the concept of this, where it's like Unreal is more performant than Unity. The problem with Unreal is not performance, right? That makes the problem is that Unreal is bloated, right? But their bloated code is performant. It's just it's bloated, right? So like doing the exact same thing in Unity is going to be slightly slower than doing the exact same thing in Unreal. So it's just like Unreal is more performant, but like it requires a bigger PC because the game, like the engine itself, is just so much bigger. Yeah. But anyway, sorry. Off of that, onto the important thing. So like I have a feeling that I'll probably use Unity for this game, whatever it's going to be. But I might use Unreal depending on like it this is largely going to depend on like the art style, which is going to be set by the other guy because he's going to be the art director, right? But yeah, effectively he's going to do the art, the animations and all of that, and then I don't know what he's going to do is the problem. So I don't know what he's planning for art yet, but he should have something, and based off of how fast he is and how good he is, I'm assuming that he'll probably have like a general, like he'll probably have a guideline for me by the end of the week, right? Maybe 2 weeks, right? But like if it takes him a month, it takes him a month, right? Like I'm not gonna put him on a timeline, right? I'm just more saying like based off of how fast I've seen him work, I could see him getting me like a general idea, so I could pick the engine and stuff like that, and we could start making the game in like a week, right? Yeah, he's pretty fast. I don't know if you know him. His name is Gaz. He's streaming on YouTube still. Um, but I'll show you some of his work. He does really good work. But I don't think that he'll use this his regular style for what we're going to do for the game. But I could be wrong, right? Let me get a still image. Here we go. Look at this. So this is his work, right? And he pumps these things out, right? So like I don't know, he can do Toonie, but he can also do like this, and he can also, I think he can also do hyper realistic. I don't think we're going to be doing hyper realistic, right? So I think we're probably going to be either something of this look or something more Toonie than this. So it's probably going to be somewhere on, this is the most realistic versus as toony as he wants to go. And I'm not sure where we're going to fall. But he said that he was going to work on something, and I sent him an idea that I had for like the gameplay, and he woke up to that, and he got to wake up to like my horrible art, my absolutely horrendous art. It's so bad. But yeah.
When I started,
Okay, what was I looking at before I got distracted here? Uh, do ECS Unity events. Ooh, this actually might be the way to go. I don't think he covers it in here because I think he's still using. I'll still pull that up though. How long ago was this? Is Unity Dots abandoned? Oh, 3 years ago.
Okay, so here our code is done.
You know what? I think I can just jump on a second part, another thing inside of that list that's very, very relevant to making the crawlers work well.
Okay.
It's like tied in between. So I think I had somewhere in the list data-based events or something.
Well, that is perfect because that is currently leading in the poll right now. So
Really?
yeah.
Yeah. So this is riffing off when you talked about how damage propagation in your damage system. I don't remember exactly what you call everything, but it's like a pretty good way of dealing with damage.
Yeah, kind of like the capability system and having the damage events and all that. Yeah.
Yeah. So let's just get a few ground rules here around how we should view this problem. So first of all, problem with the crawlers, or not the biggest problem, maybe the biggest. I haven't really seen, but one of the actual biggest thing is
it is. I specifically was using the invoke Unity events. So as long as I can use invoke Unity events, then we're golden. Because that's what I'm familiar with right now.
isn't really the movement code. That is continuously updating, right, and doing all every frame, and it's very, very necessary to optimize as fast as possible. But an equally big problem is the cascade of things that happens when you kill them or something else will happen with them. So imagine when you shoot one crawlers, you're supposed to have a sound, a VFX, and then maybe count up some counter that you kill them, and then maybe spawn some remnants of some sorts. So there's like, and imagine you're having like a shotgun and you shoot like 100 projectiles and you kill like 50 crawlers at the same time, and then all the crawlers have like, I don't know, 10 different sub things that happens because of their death. Then you get
like
500.
They play an animation or do some sound effects or add to the score of the player or something.
Yeah. Oh, animation. Let's keep that on the back burner. I can show you how they animate it after we're done with this one.
Cool.
But yeah, the cascade effect is very, very hard to deal with. And in Unity, in traditional Unity, you have the problem like, oh, I want to have a lot of enemies, and then you shoot one and you make a really cool effect, and then you put in the death effect, and you put 100 enemies and you throw a grenade and it just like lag spikes because you instanced in 500 explosions. Unity game object instancing is like the slowest shit ever. It's super bad. But dots doesn't really solve it all the way either. You still have to deal with effects and stuff that is not dots compatible yet. And even if everything was dots, you still would probably run into issues with the frame dip or spikes when you have this cascade. So how do we deal with this? Part of it would be like to rate limit it over frames. And that's also something I do. And that's, you can imagine how that is. You have a backlog, and if you go over a certain threshold, you throw it into the backlog, and you wait for the next frame and stuff like that. But this cascade, part of the reason why it can be so slow is if you use slow systems like entity command buffers. Entity command buffers is great when you're dealing with, and it's very, very versatile when you're doing the example you had last time. Then it's a perfect solution for it. But if you have 50 of them having at the same time, then in the same frame, that's going to be a problem. So now it's the data without entity. Remember, one of the reasons why entity is a thing is because it needs to be globally addressable. Like you have this entity, you have a bunch of data connected to it, and you want to be able to identify that one, right? That's part of the reason why you have it as an entity.
Right.
But in your case, with your damage, or in my case with damage, or with something else like an event that happens, the identification of the event is not necessary. It's just like this victim got hurt with this damage. Like the identity of the data is not really relevant. It's just like you got hurt. Like my identity as a messenger is irrelevant in that case. So you have this entity with an ID that is perfectly globally addressable, has no real use. Like when you read the incoming damage events, you didn't care about the entity index, right? It's you have your damage and you have the target which take the damage and that's it, right?
Right. Yeah. I think in that case I didn't, but I do see that there are like some times where you might want that information as well.
Yeah, but also like there's a difference here. You don't necessarily need to be globally identified. You can have a local identification, but entities is globally identified amongst every entity in the whole system, right? And that's not really relevant for a lot of stuff. And this applies to a lot of situations. Like ask yourself before you make it an entity, like, is this really needed to be identified, or can I like do it without this global identification process?
Okay. One sec. Health. Spawners. Random walk. Health bar. Melee attacks. Move override? I'll be right back. Okay, I'm back. Sorry about that. Okay, I need to find something that's just talking about actually just integrating these things instead of like a lot of roundabout stuff. I don't like the podcast format for a tutorial like this. Um, oh, it's this guy. Oh wait, all right, he's using Unreal. Dots. What was it? Events. How to handle events in Unity. It's 4 years ago though. Advanced coding tips for beginning. What are events? Collections and triggers in dots. That's old version of ECS. I looked at this and it has some idea. 2 years ago, we can definitely take a look at that. This actually has some stuff in it that's probably good. We can definitely take a look at that, but it's only 18 minutes, so I can't imagine they'd be doing too much. Do not convert your Unity engine. 4 years ago. This is I new input system. I should probably have done this.
Hello everybody and welcome to today's video. We're going to be talking about using the input system with Unity's data-oriented technology stack and their entity component system. And of course, many videos on my channel focus around Unity Dots. And so now that Unity Dots is fully supported and production ready as of the 2022 LTS launch, I think it's really important that we talk about some of the topics about how to start integrating different features of the Unity game engine or just kind of general important things to game development into our Unity Dots projects. Now we already have seen a number of production ready games available. Here's just a couple examples of them. By the way, if you're not familiar with Unity Dots, here's kind of some of the features. It's kind of centered around the entity component system, and there's also the job system, the burst compiler. Another important factor is netcode for entities. I did a whole video kind of going into detail about what Dots is and should you use it. I'll have a link to that video down in the description for you if you need it. But really the main point that I want to get across is Dots is kind of a different way of thinking about things because it uses data-oriented design rather than object-oriented programming. So we kind of do have to approach integrating things like the input system and UI in different ways. So I do want to make a bunch of videos, kind of talking about these topics. So if you have any suggestions for things that you'd like to see, feel free to leave those down in the comment section below. But anyways, getting back to today's video, what we're going to be talking about is the input system. Now this is kind of the newer input system that's actually been out for a couple years now, but it's just a really flexible and good system that allows us to basically configure all different types of control schemes for different types of input, whether our games that we're targeting are for PC, mobile, console, anything like that. We can easily set up different control schemes and input actions to support all of these. So it's just a really great and flexible system, and it's something that I would highly recommend using in your Unity project by default. Now, anyways, today's video is not going to be an in-depth look into the input system. I'm going to be showing you, everything that you need to set up in order to get your project working with Dots, even if you've never touched the input system before. So it may be an introduction for some people, but I would highly encourage you to go do some more research into the input system because there are a lot of different things that you can do with it. So I'm going to go ahead and leave some links down in the description for some of my favorite resources for learning about the new input system. So anyways, talking a little bit about how we actually use this with Dots, there's kind of a couple steps that we need to go through to basically handle our input actions. Now, the first thing that we need to do is actually create and configure our input asset. So this is something that we need to do with the new input system. We basically create this asset, and this is where we map kind of our key bindings. Basically we can say this is where we press the WASD keys to move the player around, or we can press the spacebar to make the player jump. This is kind of where we just define all of the base input actions that our player is going to be dealing with. Next is when we get into some of the Dot specific stuff. We're actually going to create a system base system, which is actually going to read our input. Now we're going to put this system base in sort of the initialization system group, which is kind of the first step of the ECS player loop, and that's what's going to happen before all of our gameplay systems. The reason we do this because also in the system we're going to be writing these results to a data component. Typically it's going to be a singleton data component, but maybe there are some circumstances where you would want to write data to a specific entity over another one. But in this case we're just going to be using a singleton data component. Now once we've written to that, again we're writing to that in the initialization group, we can have any systems kind of in our main simulation system group basically read that input data. So again, we're only really reading data from the input system just at one time, and then we're setting up a component that can be referenced from any other one of our systems. So this is really nice. Again, we're just kind of getting input from our player in just one spot, and then many other systems can reference that data as needed that can do different things. So as an example, let's say when the player presses the spacebar, it's going to cause the player to jump. Well, what we can do is actually have multiple systems to essentially reference that component that has been written to know when the player needs to jump, and we can have one system that actually begins performing the jump, and we can have another system that maybe can play some sound effects or maybe decrease some stamina. So these things can kind of all be separate, and it kind of lends into that data-oriented design pattern. And then anyways, the final thing that we may or may not need to do is reset our input data. And so there are some circumstances that we may need to do this and other circumstances that we won't necessarily need to do this. And that is because it's actually going to be two ways that I'm going to be showing you how to read input today. So the first way is to just continuously read input. So this is good for, if we have any player joystick movements, if the player's kind of just moving the joystick around to move their player around, we can continuously read that because it's
so this is definitely something we need.
It's also valid for when the player is not touching the joystick that we don't want the player to continue moving. Same thing for if we had like a trigger on a controller that we wanted to use to control how quickly a car is accelerating, we can continuously read that value and see what percentage and kind of where that trigger is at in its travel, so we know how much acceleration force to apply to the car in our game. The other option is kind of more an event-based approach, and this is best for when we're pressing buttons. We're not going to be continuously reading what the value of that button is. Basically, we're going to have an event-based approach where we're going to kind of hook into some of the existing Unity input systems events so that we know when a key is pressed or released, that we can kind of write to the proper data component. So again, this would be good for any type of inputs where the player needs to press a button for something to happen. Maybe they're interacting with something in the world or so on. And this would be one of those cases where maybe
we're effectively only going to be using the continuous read stuff.
Writing to a data component, and at the end of the frame, we're actually going to need to reset it. So I'm going to be showing you how to do all that here right now. Okay, so here we are over Unity. Again, the first thing we need to do is create our input actions asset. Basically, the way that we can do that is just right click in our project view here, go for create, and then all the way down to input actions. Now we can go ahead and say call this the demo movement actions. And we just go ahead and double click this to open up the window here. So again, we're just doing a very simple setup here. So first we're going to go ahead and create an action map, and we can just go ahead and call this the demo map. Now we can just like that. Now before we add we are looking for. Now we just go and then over here click on this and we can go ahead and different D and arrow keys of analog or digital mode. So just go ahead and keep that in mind. Okay, great. So once we have our player fast when we're moving in a diagonal direction. One more over, it's basically just normalizing that vector to be a length of 1. You'll see that our composite type is a 2D vector. Again, we want the XY axis for if the player is pressing up, down, or left to right. And our mode is also going to be set to digital normalize. I typically use this, and that's because for say pressing the W and A keys to move up and to the left, it's basically just normalizing that vector to be a length of 1, so that when we say multiply by our move speed, we're not moving extra.
Oh wait, did I do that? That's actually important. Let's take a look. I don't think it's something that I have. Yeah, it's not something that I have. It's fine.
fast when we're moving in a diagonal direction. However, it may be different for your game, so maybe you want an analog or digital mode, so just go ahead and keep that in mind. Okay, great. So once we have our player movement set up, we're gonna go ahead and add in.
Do I even have any vector 2s? Not really. Yeah. No, just steering. But steering is only left and right. Yeah, no, it's fine. Okay.
One more action, this is going to be our jump action, so we can just call this, say, player jump. And then here, we're just going to go ahead and set up one binding. We'll just use this as the space key, so we'll just go ahead and add the space key there. Now, very important that once we're done, we can just go ahead and click Save Assets, and that's actually just going to go ahead and save the assets. Now we can close that. Next important thing that we need to do is we need to generate a C# class so we can access these input actions from our system base. So go ahead and checkmark that box, and then click Apply, and you'll see it's going to go ahead and take a moment to actually go ahead and generate this new class file here. As you can see, this is actually the class file that it's automatically generated. It has kind of all the different maps and everything that we just inputted, so that's all kind of available to us to access through code now. Okay, so now we're going to go over to our IDE, and we're going to configure our system where we're actually getting input. So again, I call this the Get Player Input System. Now, like I mentioned in the theory section of this video, we're going to go ahead and actually do an update in group type of initialization system group, and I like to put this actually at the end of the initialization group, just so it's kind of running after Unity's default initialization logic. That's just kind of a personal preference for me. Again, we're doing this in the initialization system group because by default, most of our gameplay systems are going to be in the simulation system group, so that kind of guarantees that,
Requires player tag. Required for update. Player move input. Okay.
any system that's running in the simulation group that needs to, say, reference some of the input data components that we're writing to, those are always going to have the current up-to-date information for that frame because it's kind of referencing that data after it has been written to for that frame. So it's always going to be kind of the most accurate for us. So you see that I kind of have just a couple basic things set up in the system already. But one thing that I do actually need to add is our demo movement actions. So we can just go ahead and add this as a field of this system base here. Now in the onCreate, we actually need to go ahead and initialize these input actions. So the way we can do that is just by taking our demo movement actions variable, set this equal to a new demo movement actions. Now after that, in the onStartRunning, we're actually going to go ahead and do the demo movement actions.enable, which is actually going to enable the input actions, meaning that we can actually use them. And then similarly, I like to just go in the onStopRunning and just do a demo movement actions.disable, just so we know that if the system stops running, those input actions will be disabled. So now that our movement actions are properly enabled, let's go ahead and do the first approach where we're just going to be constantly reading the value from the input actions. So again, we're going to be using this for our player movement. So here we can just set up a new variable called cur_move_input. I'm going to go ahead and set this equal to our demo movement actions. And then now we need to go ahead and actually access the input map, which I just called the demo map. And then we can go ahead to actual player movement action. From here, we can go ahead and do a read value. Again, the type that we basically told the input action that it was a vector2. And so again, it's just going to be continuously reading whatever that current value from our move input is. So now once we actually have our current move input, again, this is just kind of reading it and storing it into a local variable here. We actually need to go ahead and write this. Again, we're going to be writing this to a singleton component. And so we can easily do this using the system API.setSingleton. And here we can just say a new player move input. And again, this is a custom type. I can show you what this looks like in just a second. So cur move input, just like that. So this player move input, we can go ahead and take a look at this here. You can see that this is just a public float2 value. Again, this float2 type is part of that new Unity.math.
Why are we creating a new one? That's the part that confuses me. Why are we creating a new one? Like, it is a singleton, so I guess like if it doesn't exist, it creates it, and if it does exist, then it just overrides it. It's my assumption, but like we're still
library
going
that is
through,
the fully
we're
burst
going,
compatible
still
type.
going
It's very
through
similar to
the,
what vector2 is. In fact, there is
sorry, we're still going through the process of like reallocating space theoretically.
Implicit conversion from
Depending
vector2
on
to
how that
float2, so that's how we can
happens,
just take our current input as a vector2 and add it to this movement input data as a float2. Now for this demo project, I have this player move input. This is actually living on the player entity, but there's no reason that we couldn't have, say, a dedicated input entity. There's a lot of cases where I do end up having a dedicated input entity that has all the components for any input, just kind of on its own dedicated thing here. But again, basically this on update will just continuously keep this player movement value updated. We don't have to do any resetting or anything like that, because if the player is not pressing any keys, then the player move input is just going to be set to values of 0, 0, and then when we actually go ahead and move our player and we reference our move input, the 0, 0 values are going to be meaning that it doesn't move in any direction. So I can kind of show you what this looks like. So I have this player move system here, and this is again just running in the regular simulation system group, which is just scheduling this simple player move job. Looking in here, you'll see that basically I'm going to be modifying the local transform components of our player, and it's going to be reading in from that player move input as well as our player move speed, so we can have a multiplier for how quickly the player can move. And you can see that basically what I'm doing here is just doing a transform position.xz, just because we're going to be moving our player just in the x and z axis. And then I just do a plus equals, so we're basically adding to its existing position. Our player move input.value multiplied by the move speed value multiplied by delta time. So again, this player move input, this is going to be the xy position of whatever the player is pressing. The move speed value is kind of a multiplier, so we can make the player move faster than just kind of a default here. And then finally, we'll multiply by delta time to normalize out for frame rate. And then after this is basically just saying, if the player is still pressing any keys, we're actually going to rotate the player in that proper facing direction. So if we say come over to Unity, now we can go ahead and use the W, A, S, and D keys to say move our player around. And I can also use the arrow keys to move the player around as well, because we've created both those bindings in our input map. So now the
where do you go here.
Next thing to do is to get it so we actually press the spacebar, our player shoots out a projectile. Okay, so now to show you how to actually fire a projectile again, this is going to be kind of the event-based approach for gathering input. You'll see that I basically already have this private void for the on-player shoot, and this is basically that event that we're going to call whenever the spacebar is pressed. You'll see that basically all that's happening in here is we're just making sure that the player entity still exists. If it does, we're going to go ahead and enable this fire projectile tag component, and then we have a system later on that looks for any entities with that fire projectile tag enabled, and when it is, it's just going to go ahead and enable that projectile. Again, all we're doing is just setting it to true here, and then we're going to have a system later on to kind of reset this value to false. You'll see that the on-player shoot does take in the input actions.callback context obj, and that is something required for listening into these events. So the way that we're actually going to listen to these events is, say, in the on start running, we're going to go ahead and do demo movement actions.demo map.player jump, and there are a couple of events that we can listen to, but I'm just going to go ahead and
Yeah, some things I don't get with dots is newing everything all the time. I guess the newing struct, but not classes. So it depends on why you're newing things. So the data structure for the structs is substantially smaller. So it doesn't take as much to update. But when you're newing it, it should be allocating new memory, which allocating new memory is usually bad, and you want to avoid that. Especially like when you're like destroying, like effectively you destroy the old one and add a new one. But like if you're newing and overriding, right? Like I don't know, it just seems weird too. Like the newing is weird to me. I feel like I can get it for the singleton because like a singleton, it just like overrides it, right? So I imagine it's just an easy way to like reset those values without having to make multiple calls. But yeah, the newing is so weird to me.
then listen to the performed event. So we can just say plus equals on player shoot, just like that. And then we can just go ahead and copy this line, and then we'll go ahead and move this into the on stop running. And we'll just go ahead and do a minus equals just so that event gets cleaned up if the system gets disabled. And so that's basically all that we need to do, because again, this event's basically just going to get fired, which is going to go ahead and call this method here, which is basically just, again, enabling that fire projectile tag here. So here's an example of, say, this fire projectile system here. You'll see that we're looking for, anything that has this fire projectile tag, and I'm not looking for any disabled components. So again, this query is really only going to execute when we
Okay. So this makes a lot of sense. So he's suggesting doing this as a system base. And that makes
Hello everybody, and welcome to today's video.
Okay, so oh, this is the wrong one. There we go. And close that. Then we come to here. And what we need is we need a system base. Yeah, we need a system base. Add a dots system base. And here we'll say input system. And then what we want is we want to do this update in group type of initialize system group. And then we want order last equals true. It's fine. Private movement action. What was our movement action called? Because it wasn't that. Player input actions. Player input actions. And this will be player input actions. And then we need a private of entity player entity. Then we do we need an on create, right? Protected override void on create. require for update, and then we do player tag, which I actually think I'm going to go create because I actually like that. Require for update, player move input. Kind of confused on that one, but we'll come back to it. And then player input actions equals new player input actions. And then we have protected override on start running. There's our on update, that's fine. And then we need to also do this on the override void on stop running. And here we do the player input action dot player dot, oh no, just disable. Right. And then player entity equals entity dot null. Oh, we don't want to do that there. We want to do that there. And then where do we do the enable? Oh, that's the on start running. We do the enable, right? So this would be player input action dot enable, and then player input action. Oh no, that's the perform jump. We don't need that. And then we need player entity equals system API dot get singleton. Player tag. And here's our on update. Player input action. Player. Did I call it gas? Gas? Yeah, gas. Read value float. Do okay, then we're going to come back to this. Here's our player move input, which is just a iComponent data, which is fine. We're going to come back to that. Do here, we need an authoring. Yeah, we can move this out here. Okay. And I'm just going to delete this. This is actually going to cause a problem, but that's fine. We haven't touched it in a while, so it's fine. And then we can do the old trucks. All of the old trucks we're just going to get rid of. We don't need. By the way, I enabled Git, so I have Git stuff. So we can get this stuff back if we find that we need it. Yeah, I started. We have Git. There we go. Beautiful. So this is our authoring for the player. Here's our player, right? What? What is this? Where is this? This is not at all what I want. Let's do the player authoring here, right? And all we actually want is the component, right? No, we want this. Right, so all we're going to do is we're going to come into here. We're going to place this here. Import the reference. Right, and then we're going to do this is going to be player tag. Then see, what else do we need? Player move input, player move speed, player tag. Yeah, we effectively just need all of these. We don't need these though, because we're not doing those. We can come back to those. That's fine. Right. And then this is not that. I'm debating whether or not I want like a different one for move speed and a different one for, right? Like should steering be its own thing, like public struct player steering? And this would just be a public float value, right? There is the, we don't want this. All right, let's start. Let's do some quick trimming, right? Because we want to get rid of some stuff. Yeah, okay, so get rid of that. Get rid of this. This is completely useless now. So we're going to get rid of it. Where is it? There it is, delete. We don't need this anymore. We don't need any of this anymore. We don't need this anymore. Okay, there we go. And then up here, I wanted to get rid of this. But I think like this is actually being used, right? So we go to find usage. This being used in here. Okay, so we can get rid of this player state. And that should only break player. And then player here we don't need. So let's find where player is being used. Find usage. Player's not being used anywhere anymore. So that means this isn't being used. This isn't being used, and player name is not being used. So player can now be deleted. Right? And then we've got this input here, which is also, I believe, not being used. Find usage. Yeah, it's not, so we can get rid of it. Game load info. I don't think this is being used. Find usage. It's not, so we can get rid of it. I don't think this is being used. Find usage. It's not. Is this being used? Find usage. No. Timeout. Find usage. Nope. We can delete this one now. Checkpoints is not being used. We can see strictly that it's not, so we should just be able to edit, delete. Yep. Player skin, I do not believe is being used. It is not. We can delete that. Look at that. We're just fucking trimming everything. Car select is not being used. We can delete. Animation curves. This actually, I think, is being used. Find usage. Yeah, it's actually being used. It's being used on the wheels. And the wheels are actually being used. Scene loader is not being used. We should be able to delete this. Vehicle, yeah, these three are the only ones that we care about from this. And there's our sweet. Okay. Controllers. We don't need this. We don't need this. Edit, delete. And we don't need these. And I don't need this. Wow, we just trimmed so much. The anti-roll stuff is being used. These are all being used. That's fine. Hittable objects we'll be using. This player we can get rid of. It's just an empty scratch test. We can get rid of these. Utils. These are my utils, right? Yeah, these are mine. All right, there we go. Cleaned house. Hell yeah. That's what I like. I like to see that player input. Player input, move input. Yeah, here. Which is here, which we'll do. Well, effectively, I thought we made this in here. Oh, it's player move speed. Right? No, player move input and then start. Wait. How does player move speed happen? There's our float value. Oh, we do it in the burst compiler. Local transform, there's our transform, move, speed, that's fine. Okay, so I kind of want to put these together, to be honest, but whatever. Required fire for update, player steering. Player tag. High component data, yeah. Is this the player authoring? No, this one's the player authoring. And then this is our player authoring. We're just going to, effectively, we're just going to copy this. Player move input. I still, yeah, let's do this. Public struct player move input. I component data. We'll say public float gas. Public float brake. Public float steering. Public float e-brake. There we go. And we don't need this move speed for this one. And then we can come over to the input system and we can just say player input. Okay, we don't need these two. Interesting. I kind of see how this works. So we add the component here for player move input to the entity, and then we use the authoring move speed from the mono behavior. No, because we don't care too much about that. Those are authoring here, right? We effectively just, no, that's move speed. Yeah, okay, yeah, we're storing that data. Never mind. Be back in a minute. Yeah, no worries. See you when you get back. I see what I was doing wrong now. Okay, yeah. We don't need this because we don't control the speed of the character through this. We control the acceleration and stuff like that. That's all that matters. Right? And then here right, we come down to the system here. I still don't know why we're not able to do this. Convert source type player tag. API is get singleton and get singleton entity. That's why. Okay. And then player move input. This is gas. This is a float. And gas value. Gas input value. And then break will do the same. This is going to be break. It's moments like this that I wish that I had I still had my sub, but whatever. Float steer. Oops. Steering input value equals player player input actions dot player dot steering dot read value of float. I want to move that up. This is eBreak. I think that's it. Yeah, those are our only three values, right? Steering equals there we go. Beautiful. So what's our error? Oh. I'll be right back. Trying to get warm in here. Remember, everybody, YouTube has no ads. Oh shit, my camera. There we go. One of my cameras fucking fell. Okay. Whew. Okay, let's see where we're at here. Okay, so this does the update, and then how does this incorporate into the player move input move the actual player itself? There's that, and oh, and then from here the player move job. Okay, so we also need a byte. The is grounded. Don't worry, that's actually going to come into play. So we need a system for actually pushing the vehicle, which I think actually is in one of these components already. The vehicle component, maybe? No, that's the collision stuff. Right, gameplay. Control system? I think it comes into here, right? Schedule parallel. Ooh, sorry. Oh, here we go. Steering velocity. Wait. Going to be a bit more than a minute. Brother wants me to help him kill a boss. Lol, back in 30. Yeah, no worries, man. Here we go. Steering system. Wait. New steering job. Calculate steer amount. Wheel system steer amount. Oh. Wait. What? Wait, this is like what we want. I guess it already exists, right? Drive amount? Find usage. Oh. We already have it. Wheel drive control. Yeah, no, it's this. Okay. So instead of doing, wait, no, I want to change that. We're gonna change that. Okay, so here we've got wheel drive control. This we want the in player input. Wait, there, player authoring. We want this player move input, and then this would be gas. Drive amount. Gas. There we go. And then the steering thing is also this, and this is the player input. Wait, what was this? This was steer amount. Steering. There you go. Look at that. Okay. I think we just did it. I think we patched it in. That might actually be patched in now. We're about to find out. Let's scroll this camera out. I absolutely hate that. But let's see if it moves. The vehicle does not move. The vehicle is absolutely not moving. Do we have a console? No, we have no console errors either. I absolutely want to change that camera though. So what we want to do is we want to take this. We're gonna get rid of this. Remove component. Right. We're gonna re-enable that. We're gonna come back to here. We're gonna take these two and we're gonna delete them. We're gonna come back to here. And we're gonna save. We're gonna see the player input. We're gonna remove that. We're going to remove this player authoring and linked entity stuff. We're going to remove that. We're going to add a script, which is going to be the player input. No, what is it? Let's hit play quickly and make sure that we don't. M disabled has disappeared. Okay. So one of those we actually did need. It's probably that one, maybe? Let's double check. It's not that one. We're going to have to relaunch this because it's a little bit broken still. Uh, Fuck. Give me a second. Where is here? Third person. Oh, excuse me. Okay, so apparently I can't remove this. What about this one? What's this one? This is horribly broken now. That's cool. I can't, I can't, I can't. Wait. Remove component. There we go. Oh, thank God. Okay. So we clear, we hit play. We removed the wrong stuff. Where is this one from? Yeah, we leave that and we open up this one. I got done fucked up. I have to add back in some stuff. Vehicle authoring. Vehicle authoring. Not prefabs, scripts. Did I remove vehicle authoring? I didn't think I did. Oh, maybe I did. I think I've got some stuff to fix here effectively. Okay, but this takes the vehicle authoring like this. There's that, and then the wheel authoring. Yeah, I totally deleted something that I didn't want to delete. Yeah, so there's my get status. This one here, we want to reset this. Yeah. Okay. No, these are new. Wait, what? How did I have this working before then? Hmm. This is the wheel, right? The wheel reference, yeah. And then this is visual wheel. Visual wheel here is the player skin component. Which is under common. Or is it gameplay? No, it's under components. Okay, and then we've got this player authoring, which is, because this is taking the player. Give me a second here. So player authoring, which is next to the wheels. Player authoring, and player is, yeah, this player component here is not required, and neither is actually player authoring. Yeah, this shouldn't be required. Player authoring find usage. Okay, so we're just going to do this. But this requires the player. So this player authoring should be able to be deleted. Car input authoring. This is something we need. Potentially. But I don't want it, right? Like, I don't think we need this. We already kind of have it. Delete. There we go. Beautiful. There we go. Now if I hit play, we should. Beautiful. Okay, there we go. Whew. Okay, so we're working now. Then if we go back to his code, which is right here.
When we have this fire projectile tag enabled, and you can see that I have just a local entity command buffer where we're just basically instantiating a projectile prefab and setting it to the proper transform of the player and all that. And finally, I do just want to point out this reset input system. Basically, what this is doing, this is actually updating in the same projectile. Okay, so now we're actually here, and we'll say listen, and then we'll set the go ahead and add another piece, an arrow keys to the functions, and that, and we're going to configure our system where we're actually getting input. So again, I call this the get player input system. Now, like I mentioned in the, this is actually the class file that it's automatically generated. You know, it has kind of all the different where we're actually getting input and group type of station system to is going to go ahead and do the options are proper movement actions. Basically, this on update will just continuously keep this player.
I think all we have to do is add the player authoring right there. And then let's go to console and hit play. just going to do that. Play. Okay, now. There's the player tag. We add those two. And then the input system grabs, on update, we grab this. And there's our player input and our player tag. And then get singleton of player tag. Oh yeah, because this is creating a new one for this and it's holding it. On update, let's see if this is actually firing correctly. Debug.log, and we'll say steering input or steering, input. We're just going to do this. Steering input value. Gas input. We're going to say break input value, or just break input, sorry. This will be break input. And then what I'm going to do is I'm going to put this on its own line, and then we're going to break this here. Beautiful. Then we'll hit build. We're going to see if this is even triggering. Because this on update should only trigger if like we have the stuff required, right? And let's click here and take a look. So here we have the player tag and the input system. Sweet. Okay. And then we hit play. I'm going to keep a hold of this one. And then we're going to come down and take a look at our here. And we're going to see whether or not we actually get any data. Okay, that's working. That's working. E-brake. Oh, this is actually a button, not a... I didn't know that this was a on-off. I thought that this was more than that. Interesting. There we go. So that is actually working. Player move input. So the issue that we're running into is that the steering system is not picking it up. So if we come back to here, we grab this, we go to the steering input, and we say, hey, what type of steering do we have? Because this is going to be important. We don't care about any of this except for the steering. And this is going to be steering amount. Input direction. Okay. It's not working. Oh, wait. Steering. Is this on the wheels? It's because this isn't actually running. And this isn't running because this, I suppose, isn't actually working. It's not that. Yeah, it's not being attached to anything. No wonder. Okay, so the car input is working, but the steering is not. Do I not have steering on my wheels? Yeah, it is steering. Is on the wheels, yeah. Okay. And if we come back to here, is steering, yeah. And these are just ghost things. There's steering. Metadata for non-replicated components. So if I go here to runtime, what am I going to see on runtime for a car? Guess we have to go back to the scene, right? And we drop this bad boy in here. And we say, hey, I want this at runtime. This is authoring, but I want runtime. Seriously? Oh, right, because it's not part of excuse me. Wheel drive controls. Wheel drive controls. I don't even think I have that. Oh, no, I do. Wheel drive controls. There we go. Okay. I see what's going on here. Drive amount, steer amount. This is not what we want. We want move input system here. But what we're going to do is we're going to do that and then this, and then we can get rid of this and see what happens. Requires exactly one. Yeah. Okay. Okay. Where did I put that change? Luckily, I didn't. Here it is. Okay, so we want to see where this is, how this is being used. Find usage. God. Okay, so what is it? It's wheel drive controls. There's adding it, and then we go to control system here. That's fine. Vehicle input system. Here we go. Okay, so it's being added specifically on the wheel, I believe. Yeah, on the wheel. So we can skip over that. That's fine. And it's being added one to each wheel. And then if we go to the input system, which I believe we've entirely ripped out, vehicle control system, vehicle steering system. Yeah, we've removed it from here, which we need this to be a wheel drive control. Steer amount. And then vehicle control. This, I believe, vehicle control. Vehicle control system. Yeah. This needs to be a wheel drive control here. And then this is drive amount. I don't like the names, but we can change that later. I want to get it working with the with this new system first. Find usages. Car input is, so this is on the vehicle input, which I believe we got rid of. Yeah, we got rid of the vehicle input system. So let's bring that back over. I'm gonna bring that over, and that's under vehicle here. And then we're going to jump to it. We're going to find the net code, and we're going to say we don't need net code. We're going to remove that and remove this. We don't need a race. We do need this, which is going to be the player move input. This is where we're at here. Here we go. Like if ignore inputs, we ignore inputs if we are in countdown. Really, this should be not, because we spend more time outside of these than in them. So here's our steering amount and our drive amount, which is not what we want. This isn't actually how we want this to work. What is the chassis reference? Is just an entity value. Assigns the chassis entity to the wheel for later processing. That's fine. Wheel drive controls. Steer amount to do. This I do actually want to change this. Find usage. Okay, no. I actually do want no, because this needs to not right. This needs to be fuck. This needs to be different. Because it needs to be a singleton, right? Yeah. Then how is this working? Ooh. I think what we need is the input system. Our input system. So this is the on create, and we want the on update. And there. And then sorry. the steering and all that is causing the problem, because it's trying to attach extra stuff that we don't want. Okay, wait. This is where we need to make the change. Vehicle input job. This needs to be a player car input. Wait. This is fine for that. Wait, but then we would need this. One sec. I've got to figure out how this is going to work. Give me a sec. So we don't want that. So this singleton is not useful right now. So we have the car input. The car input is the wrong thing because that we want the player move. Right? So we do this. And then we use the get singleton. There. Then instead of car input, right, this is going to be player move input. And this is a read write for player move input. We don't care about the ghost. There. We don't need this. To do input value read only. Default? No. Oops. We just want to read it. So that would be input. This would be input. These don't seem right. Oh wait, no, because this is the input itself here. And then if we come back to our input system here, what we want to do is just put that there and we'll do this. What we want is the player input to action, right? We get this system API. We're going to fix this. Essentially, what we need to do is we need to take this and move this over to here, right? So this is fine here, right? But what we want is we want this here. Let's just put this back. There. The car input, whatever. And then we want to, there's our input, which is the car input, which is just updating that. And there's our mobile input. That's fine. To do car input. Process vehicle wheel input system. Yeah. So what we can do is we can remove this. This is not useful anymore. There. This is the job for the car input, which we replace the drive amount, right? So this find usage. just right here. Yeah. So this is the burst compiler here. And if we don't use, here's the car input. We don't need this. There we go. Yeah. Not a player tag. We need this here. There. Oops. Player move input. There. Read only true. That's fine. Wait, where is that being set? Oh, there it is. There we go. Then we don't need the race because we don't care about the race. But we are getting a singleton, but we might not need that. So I'm just going to do that. There. Car input. Oh, okay, there. Oh, it's beautiful. Okay, then here, this is drive amount. This will be gas. And this will be steering. Let's see if it works. We have errors. Errors are better than nothing, right? Car input is not declared read only. Wait. Invalid operation exception. Wheel vehicle input job. Job data dot car input is not declared read only. In job. Container does not support PAL writing. Please. Car inputs. When a component is cached by forms a minimal incremental update necessary to make the type handle safe to use. I think it's still the system, right? Wheel vehicle update job. Wait. Let's get that name. I don't think that's the one that we wanted. Hello, F. Giasisu. Sorry, I completely butchered your name there. I think the issue is wheel drive control. That one is getting updated. And it's complaining about the car input in this, which is here. This is because it's public, but we're not actually modifying it. I need to flag this as read only. Activates a write mode for all captured containers unless you add Oh, I think it's this. Car input dot no, it's not that. So there's only ever one. This is the only one that ever has this. I think this needs to change for this instead, and this needs to be system API dot get singleton entity, or at least get singleton. And this is the player input action, and then true for read only. I think that's a read only. No, okay. And this is this one here, I think. Huh. Here's the player entity. We could do the... Okay, so what we could do is this is the on update here. We could just do the... We could do this in the on update over here. But this is just effectively this here, which we could also just do this. Right? And then this is like the chassis reference. And this is ref. I think this is read only. And then it would be ref read write, which would be the wheel driver. Actually, wait. Give me a second here. I'm just thinking. If I take this here, do this, paste this in here, right? We don't have state because we're not an I system. But I think that should be fine because we're doing this. remove that. To do car input, and this would be the singleton here. Set singleton. And does this return? No, this returns nothing. So what we would want to do is we would want to do the player move input here. Struct name. No, wait. Car inputs is a is this. But this is wait, no. We want the no, we want this. Yeah, this player move input to be this. And I think we could probably get rid of that. Yeah, there. And then we can get rid of this. Do we need the chassis at this point? I don't think we do. Like this is not required. And then all we're doing is doing this. Because we only have one vehicle, right? Like the entire point of this was to make it so we had multiple vehicles. And then we could just need to do this. Right? And then now what's the problem here? That's not what we wanted. Oh, wait. Sorry. This is the, well, we want the get singleton, right? We want system API dot get singleton. And this is the player move input. Player move input. Ooh, maybe this. This might actually work. I don't want this to be read write though. So if I just do get singleton, this should be correct here. And then we can come down here and we can say player move input. And we're going to do this right after we do the set there. And then what's the problem here? Cannot resolve wheel input job. What do you mean? It's literally right here. And then I almost wonder if we can do the I system for this instead of a system base. It's possible. I'll be right back. I wonder if this can be done in an update. Actually, no, this can be done in an update. Okay, so we can do that here. And all we need to do is we do in, and this is the player move input. Yeah. And then here, we don't need this anymore. Or this. We don't need that. This isn't required anymore. We don't need that, that, or that. Build. In theory, this should work, I think, because like it's being attached to the vehicle, so, and it's updating on the vehicle, so it should theoretically work. So this is the problem here. Here, let's do this. Oh, right, because I don't think anything has both of these attached. Give me a second. I see where my problem was there. It's one sec. Yeah, no, get singleton. This is a singleton. Cannot convert. This isn't supposed to be a... I think what we can do is come down and do this. This is correct. Oh, wait. It's because of this. There. This isn't required, though. What if I do this? Just on create. But we can also just do this. So we're just going to do that. And this is going to be the player move input. There. And then we're going to just get rid of this. Wait, what was this? Redundant qualifier? Okay. There we go. This is the player move input. There we go. Get rid of the race. There's that. And then we don't need this in because it's the player move. There we go. Let's try that. It worked. It's backwards, but it worked. Did you see that? Okay, so let's move our camera back so we get a better view. This is what we really want right now. We just want to go like this. This is fine. Play. So if we just a little bit, there we go. There we go. That works. The steering's working. We don't have anything for steering, but steering is working. To be fair, I think the thing that we took from does actually have the working steering, right? So if I come down here, we delete this, right? We hit play. We should jump in and see a vehicle. Someday over the rainbow. It's not what we want. So yeah, the steering should work. It doesn't currently, but the steering should work. There we go. So now we just got to figure out the steering. Why is steering not working? So we can see that the steering does actually cause this to happen. So with that being said, our steering should be working. Calculating steering angle. What's the issue here? Ugh. Find out. Leak detected. We will come back to that. I do actually want to fix that, and it's going to be important to fix. But at the moment, I don't think that it matters. The first things first is let's get the vehicle actually driving straight. So this is the wheel. The steering angle is completely busted. Just does not at all do what we want. Vehicle authoring. It's the steering system. What we want is the input system. Here. Yeah. Okay, so here's the one that I believe we're so this is the problem here, I think. Drive them out. Yeah, it's probably this. So if we do a debug dot log drive amount, let's build. We hit play. Okay. So if I take this vehicle here and turn it 180 degrees, right? And then hit play again. Do we go in? Okay, yeah. So it's just entirely backwards. Because the rotation is there's an issue with the rotation here. That's not what we want. Transform. Wait. Chassis reference. Where are we getting the chassis reference? Vehicle authoring. Here's the vehicle authoring. Where's our chassis reference? Value entity. Vehicle. Yeah, I don't have it set anywhere. So where is it getting this? Vehicle baking data? Entity wheel visual 0, 1, 2, 3. Authoring vehicle authoring. Why is it backwards? Oh. Where's the vehicle authoring? Here. This is where we're setting it. No, this is an on update. That's not where we're setting it. Which is related to the baking authoring dot value. Whew, excuse me. Okay, and then that's authoring. Body collision mask. Baker vehicle authoring. We dump this here. Hmm. Ugh. Yeah, so we want the forward, the local forward. I feel like the correct answer is not to deal with rotation. Figure out local forward vector. Let's see, this transform parent, inverse transform direction. I get the local right vector. That's not what I want. How to calculate local offset of, how to calculate the forward up right vector. This is what we want. I think the answer, because like if we go back to here, let's see what is this type that we're getting back. This is a float 3. I do not like that they make that like not explicitly whatever. Okay. Figure out forward vector based on. Actually, wait, why are we figuring this out? Why aren't we not just using the transform dot forward? Like why Why is this not what we're doing? This is my main question at this point. Will this just work? Like we have the right, we have the app, we theoretically have the forward. Does this work? It's backwards still. Damn it. So why is it backwards? Okay, so if this is the play, what if I do 0 on this again? Hit save, right? And then I go again. We still go backwards. Okay. Why is that being weird? Where's our forward vector coming from? I think so. You know what? It's probably that. Give me one moment here. How would I tell if it's pointing the right direction? Like it could be pointing this direction and just look like it's pointing this direction. But I'm not sure how to detect that. Oh, is that all it is? If that's the case, we are giving it. So we are giving it a positive value and it's moving in the wrong direction. So I'm assuming then that my sorry, you mean inverse and not increase? We can try. And I have a feeling this will go. Wait. Are we using the forward vector? What if I do this? Okay, yeah, it's it's the vehicle. It's literally just the mesh. So I rotate the mesh. This is just the mesh, right? Just the chassis. This here, if I rotate this, it will go the opposite direction. So it is pointing backwards, right? So like if this is 0, then it will go in a different it will still go backwards, right? Yeah. So it is 100% my mesh, I think. Which sucks. Cuz now I have to reposition my freaking wheels. Hate repositioning the wheels. Wonder if there's a way to like rotate. Oh, that could just yeah, no, that makes sense. It leans back, right? Because of torque. That's fine. Still, the steering doesn't work. Are we back? Okay, we're back. So it does actually the vehicle moves in so like if we look at it right, the front of the vehicle is going to touch the ground effectively, right? Actually, is that right? Actually, it might be right. I don't I feel no, I feel like that's wrong. This is going the right way. Yeah, no, this is wrong. What the fuck is going on there? So weird. Yeah, no, it's just straight going in the wrong direction here. What if I just do this? You know what? I probably just have the wrong values. Oh, you know what? I think yeah, like wait. That's not right either. This math is wrong. Well, it's an all-wheel drive vehicle, right? Okay, so that's correct. Yes. Yes. Right? Yes. 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 Rear wheels? Yes. Yes and yes. Okay. The wheels, so either your mesh is right and your physics are right and the direction is wrong, or the physics are wrong. Right now I'm leaning towards the physics. Yeah, because it should be going the other way. Yeah, I'm thinking physics are wrong. Because yeah, it should be lifting the back. I mean the front, not the back. Like like what the fuck? Yeah, not the back. Local forward. Uh maybe. Hmm. Oh, I see. Wait, this is probably the problem right here. Let's try this. Actually, wait, one sec. We're just going to do this. There. And then what we're going to do is we're just going to do this. Got vehicle moving and resting correctly. Okay. Well, it's moving forwards now. So it moves in the right direction. I wonder if this is if this is registered as front wheel drive, and that might be the problem. Because if it's front wheel drive and we put just a metric fuck ton of torque into the front wheels, I feel like it could matter, right? Because like if the back wheels slip because of how much torque is in the vehicle, right? Because like we're literally just going for like max torque right now. We don't have like an actual torque curve. It's just like immediately as much power on the front wheels as possible, right? So if that's the case, I suppose it is possible that the front wheels have enough torque to push it that way, right? Because you would expect a back wheel because like a rear wheel drive, when the wheels go to spin, it should pop it up, right? And then like theoretically, a front wheel drive should be flat, because you never have that much torque, right? That's my thought. That's my thought. Let's figure out what wheels this is getting applied to, though. I think that the wheels do have friction. They have like a torque, so they have grip and they have slip, right? And if we're only applying force, like if we're only utilizing force from the front wheels, that could cause a situation, instead of it being an all-wheel drive, which it's supposed to be an all-wheel drive, right? That could theoretically maybe be the problem. Wheel dot drive force. I wonder if that's it though. Well, the only thing you could be right. I'm not saying that you're wrong, right? Because obviously there's the great possibility that you're entirely correct. But I don't actually know which wheels themselves are being are having that which wheels actually have drive attached to them. let's see if there's any difference between the wheels. All right, so we have this. We click here. We want to see the runtime. Okay, there we go. So let's take a look at this. There's the drive force. Here we go. No, drive force is being applied to the rear wheels as well. But in the wrong direction. What about the front? One sec. Where's the drive? No, drive here is also the wrong direction. It's minus 80. It's supposed to be... Why is it minus 80? How are we getting a minus value? Like, I guess that's why this math ABS was here, right? Because we wanted to turn it into that. But like, there's that. There's the speed. And then we want the wheel velocity. Wheel hit data. Or sorry, wheel hit. Okay, well, I forgot to do something. This. Oh, yeah. When did I put that there? Why did I put that there? So I know why I put that there. Okay, so I think this is going to go in the opposite direction now, right? Yeah, okay, that's fine. This, and then we do 180. There we go. Now add ABS math. We have, I believe we have ABS math now. Yeah, we've got the ABS now. Now what happens if we remove ABS? Because this isn't getting a float. This is only getting, like, this isn't getting an unsigned float. This is getting sorry, this is effectively getting an unsigned float, yeah. Yeah, I added it back. I added it back while nobody was looking. Okay, so let's see. We've got speed. We've got speed, which is 10. Drive amount, which is whatever we apply for it, like whatever our trigger is. So it does apply force. It does apply drive force to all the wheels. So this is an all-wheel drive vehicle, right? So if I go here and I go to runtime, we can see drive force. Let's go back down to drive force, drive force, drive force, drive force, right? So these are the front wheels. Let's apply a little bit there. We saw it. This one. Drive force. See a back wheel here? Drive force. Yeah, there. Okay. So it is just no, it's not because it's still going in the wrong direction. Like the forces the spring forces are in the wrong direction. I haven't touched the mesh. I've rotated the entire object. But like if I rotate this body here 180 degrees, it will be correct, I believe. But it will still in the wrong direction, right? Like it picks up in the wrong direction. There's something fucky with these physics. Because this is the problem right here, right? Actually, maybe. Let's try this. Because this is where we actually apply the transform. So this is applying the physics, right? So I think this is wrong. What if we ask for world data? What if we do that instead of where's the chassis transform? Yeah, what if we just say what if we're like, hey, in world sorry, local to world. Local to world. Local to world forward. Local to world right dot right. This might need to be just the local transform. So, it's so wrong. It's so wrong. Mhm. Local transform. What the fuck was that? That's great. That's actually amazing. Let's focus on that. Let's do this. No, I'm down a bit more. Like that, right? Wait for it. Wait. I wish there was an easy way to figure out which direction is actual forward. Hmm. Like which direction is forwards? Why is that so difficult? Local transform lookup. Then why are we adding the impulse? Wait. Apply impulse. The point in world space that we're applying the impulse to, right? That's here. This is the wheel center. Is that actually what we want to like actually put it on the wheel? I want name. Name, god damn it. It does work here, right? So we if this driving just feels like shit though. But this is just a demo, like to a proof of demo proof of concept from Unity, so I don't expect it to feel great. I want to say like, how are they doing the which what is where is this located is the question. So definitely don't load the common. Need to not load common. There. There's track and then lobby, colliders. Where's the player though? There's player controller? What if we go to, what if we just do start? Where's our player though? Hmm.
Set and our
Hmm. Uh, it's applying it to the wheel. Drive force job. Okay, yeah. This is the one that we were looking at here that does the math. I feel like these are the problems here. They're not correct. The suspension job is interesting. This is something that I actually wanted. This effectively here. This is the reason why we switched to this system. I wish that Unity had a forward vector like Unreal does. Like that's actually something that I think Unity is lacking the ability to have a forward vector. I might be able to try and put one in. But like, I don't know why they just don't have one. When I say a forward vector, I don't mean like the vector, like the actual thing behind the scenes. What I mean is like, so like if we open up a Unreal character controller, right? The Unreal character controller has an actual arrow. So you can visually see at all times where the forward is, right? Like if I open up any character, blueprints. Yeah. So if I like open up this character, come to here. See, this is this arrow here. That arrow is not actually ever, it's not rendered in game. It's entirely just editor focused. And it just tells you what direction your character is pointing in. So that way, if you like plop one of these down into the world, you know exactly which direction this character is pointing at all times. Right? So it doesn't matter like that the mesh direction doesn't really matter that much. It's just it is pointing this direction. Being able to have something like that is if it feels like an I don't understand why Unity doesn't have it. Like they don't have an arrow that's entirely based off of editor stuff. Wheel raycast job, that's wheel force job. Wheel hit data. So if it has hit data, that just means if it's on the ground, right? We can apply force to it. Then I guess the question is, in that situation, does the back wheel ever get any of this? Which is kind of the question at hand, right? But the wheel hit data doesn't come with enough information to determine that. See, find usage. Local transform. Oops. Mhm. Can we get the name? This has the index. So if we do debug.log, debug.log, entity ID. So this largely does feel correct. Wheel hit data. Wheel hit data is here. Add component wheel hit data. Mhm. Why are you wrong, wheel force? It's applying to the wrong wheels, I think. It's the only thing I can think of. Hmm. So I think this is applying to each wheel. Sorry, not physics world. Actually, I guess it is physics world, right? Why is it physics world like this? I don't like that. We shouldn't be overriding things. There we go. Actually, I wonder if that's actually the problem. Like what if that's the problem? I would kind of find that hilarious. It's not, but you know, the possibility was not zero. Here we go. So it's physicsworld.get. Would it be rigid body index? I don't think it's rigid body index. We can try it though. I think this is just going to return 0. Entity.index. It's entity.index that I wanted. Damn it. So it is all 4. So it is all 4 of them are receiving power. Is it possible that my center of mass is too far forward? Okay, so what if I clear this? Wait, was that actually it? It definitely feels better. Oh my god, I think that was it. Look, watch. Maybe? No, it's still going the wrong way. Wait. No, never mind. Okay. Okay, our Z before was 0.319, 0.4. Moving in the wrong direction. Rear left. These are backwards. Rear, rear left, rear right, front front left, which is actually front right. I wonder if that might have anything to do with the issue that my wheels were backwards. Like it doesn't seem like it, but still that was that was interesting. It still feels like a little bit like this feels like a front wheel drive. As in like the back wheels are slipping and going up because all the force is on the front wheels, right? What's the slip on the back? The grip factor is higher on the back, so it should not be the case. What happens if I do steering on the back too? Let's just do that. Still going the wrong way. Okay. Realistically, the front is whatever the steering direction is. And the forward vector never should change, right? I think I'm gonna have lunch. I will be back in a couple. In the meantime, I'm gonna play a bunch of ads so we don't have to deal with them for a while. All right, we're gonna figure this out. Hopefully today, before I go insane. I want to see if my other buttons work. Does forward work? Yeah, forward works. So this is doing 4 different wheels. What if we only do a forward vector? Well, well, I figured that one out. Okay. This here is the suspension. This is what we care about here, maybe? Wait a second. Oh no, okay, there's 4. Okay. Okay, so we can safely say that we have 4. What the fuck? Okay, okay. There's torque. Let's do drive force. Okay. Drive force. Let's do speed normalized. Then let's do local forward. Wait. This is drive force. What is this? This is vehicle debug system. Ugh. Our wheels aren't rotating either. Hmm. This drive force, though. feel like drive force should be able to be should drive force be applied to the wheel or should it be applied to the individual? Hmm. Hmm. Okay, so now we have movement. Okay, so this is suspension. Okay. So the suspension works. We might have to do a little bit of like tweaking on it eventually, but the suspension for the most part works. Unity.
Offset and our velocity, but then we plug those in and we have our formula right there, offset times strength minus velocity times damping, and then that force is applied at the position of this particular tire. Okay, so here's a look at a car with just those green suspension forces implemented, and you can see we're able to keep the car up off the ground now. But if we bump into the car and send it moving, we've got shocks, but we have absolutely no traction whatsoever, so good job, we made a hovercraft. Okay, so as the car's driving along here, what we can do is we can zoom in on each individual tire and get the velocity of that individual tire, which is just the velocity of that point on the car's rigid body. And then we can break this up into our blue and our red directions. So the blue direction, of course, is the direction the tire likes to roll, and the red direction is the direction the tire doesn't like to slide. And so we can take the current velocity for each tire, which in this case is this orange arrow, and we can use a dot product to break it up into two separate components. The component that's going in the rolling direction, the blue direction, and the component that is in the sliding direction. And now we're going to currently focus our attention on the red direction because that's the force we're calculating right now. It's going to produce steering.
I'm going to try something. That's totally not it. But that does actually make I think this does make sense a little bit. Because the rear wheels have more grip friction than the front wheels. So I think that makes them stickier. Mm. Let's do this. So I think I know what the problem is. I think I now know what the problem is. This is not the wheel transform. So what if we do this one's fine here. We're gonna say bucket for that one, and for this one we want float 3 local forward, right? And then we're gonna say wheel transform dot forward. Hmm. Oops. I figured out what I was doing wrong. Okay. Yeah, red is forwards. That does make sense. Okay. We fixed part of the problem. Hmm. Sort of. Hmm. Hmm. Now, if we do local up, local forward, local right, what do we get? Right? Like the question becomes, do we get the correct anything? You gotta be kidding me. It's correct. Okay. I think the up force is the problem. Sakes. Okay.
So if we just think about this, this is the current velocity of the tire in the direction of the red line, the direction we don't want to be sliding. And so we're going to need to calculate some sort of force that says, don't slide in this red direction, right? Ultimately, we don't really want any velocity in the red direction because that velocity means the tire is slipping sideways. So we're going to calculate some kind of force for this. And force, of course, is mass times acceleration. So if we want a force, we can think about it in terms of an acceleration. And an acceleration is just a change in velocity. So what we can do is ask ourselves, what change in velocity would we like to occur? Well, actually, that's pretty straightforward because we currently have this gray line. That is the current velocity in the direction of the red sliding direction. And we don't want any of that velocity to exist. We don't want to slide sideways. So really what we want is a change in velocity that is the opposite. We want to remove all of this velocity. So if we just take that current velocity and flip its direction, that's the change we would like to have occur. And at this moment, when we flip it, we could also, for example, scale it down a little bit and say, well, we're okay with the tire sliding a little bit, so maybe we're only going to try and remove 50% of the velocity. Or the car should be sliding a lot right now, we're on ice, so let's only remove maybe 10% of the velocity. But basically what we're going to do is we're going to take the current velocity of the tire in the sliding direction, and we're going to flip it around. And that then is a change in velocity that we want to have happen. So we take that vector, we divide it by some amount of time, a small amount of time to say, this is the acceleration we want to change in velocity over time. And then that value becomes our force. So here you can see, if we just take the velocity in the red direction and we completely negate it and use that as our force, here's a car example with 100% grip. And you can see the tires do not like to slide. And of course, they're so grippy that maybe the car will flip over depending on things like the center of mass. Now here's an example where we're only canceling out 5% of the slip velocity. And now you can see we've got real slidey car. This is a front wheel drive car, by the way, so it's not going to spin out too much, but it is really slidey. And now we've made a drifting game just by saying we have basically 5% traction in the red direction. And then here's another example where now the front tires have 30% grip, the rear tires have 5% grip, and it's a rear wheel drive car. And now you can see this car really likes to spin out. I'm not even steering right now. We're still doing donuts. And so, this gives you a lot of control over the car that you can think of in simple terms of just how much grip do we want to retain as a percentage for each tire.
Yeah.
Now, in our game, we don't just use a fixed value like this. We actually use a lookup curve. And so this is slightly complicated, but basically what you can see here is that the x-axis you can think of as how much of the tire's velocity is in the red direction right now. So 0 would mean the tire's not sliding at all, it's just rolling forward perfectly like it is right now. And 1.0 would mean the tire's completely sliding sideways. So we take that, and we use that number, how much is the tire sliding as a percentage of velocity, to look up into these curves here to decide how much traction should the tire have right now. So 1.0 would mean full traction, let's get rid of all the velocity in the sliding direction. And 0.0 would mean we don't care at all, let it slide. And you can see by the shape of the curve here that basically what we have is if the tires aren't slipping too much, they have a lot of traction. But once they start sliding too much, they lose tons of traction and become really slippery. And this is based loosely on how real tires work. Tires have a lot of grip at first because the rubber is kind of stretching and maintaining contact with the ground. And at some point, they start to slide. And when they start to slide, of course, the friction drops. And so these are just two curves here. I've got curves for the front tires and the back tires tuned separately to give the car the feel I'm looking for. But ultimately in our game, this is how we implemented the feel we wanted. We used a simple curve that we could just draw and test to get the behavior we were looking for. Here's a look at how that is in code. And you can see again, we have a little setup here where we work out things like the velocity in the
steer direction. Steer. Oh, here we go. This is the one that I want.
All right, so now we're down to the last force we need to calculate, which is in this blue direction. And it's comparatively simple because all we really need to do is apply some force in the blue direction, and whichever direction the force is, the tires are going to slowly roll in that direction. So what we really need to work out is what kind of forces to apply to do things like accelerate and brake the car. A simple approach for acceleration would be when the player is pressing the accelerator, we just apply a constant force in the blue direction. Let's say 100. Go. 100, 100, 100, 100. Right. Constant force equals constant acceleration. And so the car's just going to kind of speed up forever. So we need something slightly more sophisticated. And in our game, we went with this simple animation curve that kind of represents the power or the torque of the car's virtual engine. And basically what you can see here is the amount of torque, or sort of forward force in this blue direction, is based on this lookup curve. And the curve is basically saying how fast is the car going right now. If the car's at a standstill, then we get 50% of our total power of our engine. And when the car's kind of going at like mid-speed here, we have access to full torque. And then as we approach our top speed, the torque drops down. And so the horizontal axis here is just how fast is the car going compared to its top speed. And top speed is just a number that we select, right? So let's say the top speed of the car is 10 units per second. Then right now it's going at 10 units per second, so we have no access to the torque. But now we're going 0 units per second, so we have access to 50% of our torque. And so that 50% or 100% of our torque, again, is just a multiplier on some number, which is how strong is the engine, which is just the force value we've decided. And this is roughly based on real engines that have less torque down at low RPMs, and then they have like a band of their maximum torque, and then the torque drops off as they sort of redline or start spinning really fast as you get up to top speed. And this was enough for us to get a somewhat realistic car that behaved in a way we could easily tune and control with just one curve. Okay, now that gets the car going, but what about stopping the car? Well, it turns out we've already solved this problem, because stopping the car is the exact same thing as steering the car. Remember that the force in the red direction for steering was basically saying, hey, I don't want any velocity in the red direction. Tires don't like to slip, so let's calculate a force to remove velocity in that direction. Well, when the brakes are applied, we're doing the exact same thing. We want to basically remove any velocity in this rolling direction. And so we do the exact same math we do for steering, except in the blue direction this time to produce a braking force. And you can do other things with this, like you can put a maximum value on it and clamp it so that your brakes have some kind of maximum force they can apply to slowly bring the car to a stop. And you can also add things like rolling friction, which work very similarly, which is when you're not pressing the gas, we apply a light braking force in the opposite direction to slow the tires down to a stop. Here's a quick look at the acceleration code, and you can see basically we're just working out the car's
Yeah, it's the forward direction. Yeah, let's take a look at this. There's available torque and acceleration direction. Yeah, that should just be it, right? And it's 100% fucked up. I'm gonna try something. I don't think this is going to work, but I'm gonna try this anyways. What if these are just fucked, right? Rear left, rear right, front left, front right. Wait. No, it's still 100% fucked. So the mesh is definitely in the wrong direction. Like the main mesh is definitely in the wrong direction. So I should be able to fix that. Mm. Houdini export. Sorry. No. Unity F Unity endedness. Don't think that I have the project right now, but yeah, there's no recent projects. But if I set the recent projects, we can do that, and then we'll have it. Houdini projects and Dracoon accept. There we go. Then if we go to job, here we go, FBX, vehicles, default truck. There's our truck. Okay, and this is Y up right-handed. No, Y up left-handed. That's what we want. And then let's do a transform. There we go. not right. That's not right. God damn it. Wait, no, that is right. Okay, and then let's get the wheels. There's the back wheel. This is back wheel. And this is front wheel. Save. Save. Re-import. Hmm. I almost feel like I know what's going on, and I feel like it's the rigid body. Because it's so front. I feel like it might be the rigid body because like it's obviously backwards somehow. Everything is backwards. So how would I update this? If I do this, let's delete this truck. And then we'll bring it back. Here, prefabs, prefabs, prefabs. Prefab. Do. Okay, here we go. It helps if I put it in the environment, you know? Is there a way to tell what the forward vector is on this? All right, so I think it's the Z that we want to edit. Yeah, okay, so the forward vector, I think, is backwards on this wheel itself, right? Because in theory, this truck body should want to go. Yeah, okay. So if that's the case, then maybe the answer is to reload this mesh, come here, reload. Okay. Re-import. Okay, so this is pointing the correct direction now, right? No, it's still backwards. Reload. Okay, so this is Y up left-handedness, which is supposed to be Unity. Unity is supposed to be Y up left-handedness. I'm gonna try something. Where's it being used? Can I clear this? That's not what I wanted to do. Sure, there we go. I want to do the same for these meshes too. Now I should be able to delete this. Now, if I import them, C drive, Houdini, Houdini projects, TruckTune, FBX, vehicles, NPCs, not sports car, default track. We want these, import. There we go. And then we go to game. And we just want to bring in this truck here. Wait, game? Oh, thank you. Here we go. No, scene. There. Okay, yeah. Oh, look at that. It's upside down. So these are still broken. Reload geometry. How many times do I have to reload it? Okay, there we go. I bet it's this. This is probably the problem. There we go. Okay, there we go. We got that working. And what about the front wheel? Is the front wheel correct? Yep. There we go. This is a front wheel. Oops. Ah, it doesn't really matter. We'll rename these correctly in a second here. There we go. There we go. Beautiful. This is totally not going to work properly, but the the important thing is that it actually might. Oh my god, it worked. Look at that. We fixed the fucking problem. Hmm. Oh no, we do. Holy shit, we have steering. I didn't even realize that we had steering. It's backwards, but we have steering. Holy shit. We have steering. Everything's coming up, Millhouse. Here we go. Look at that. We have steering. Whee! Mm. Today has been a very productive day. We got this working. We've got a couple more things that need to be done. But the fact that we got this working is freaking amazing. So our main camera we need to bring down. Right, so we'll bring this down like so, up like so, rotate it so, bring this up and over. There we go. So yes, we need to adjust the wheels so the wheels are in the right spots, but this works. We need to fix the traction because our traction is all kinds of fucked up. But the important thing is that things are working. Oh, I'm so happy. Oh. Okay, let's see. Oh. With steering, the wheels don't move though. Like the wheels don't even they don't even spin. They're just gliding. But that's fine. It's fine for now. It's gonna have to be fixed at some point, but like right now is not the time to be fixing that. Oh, god damn. Hmm. All right, so let's see. Tomorrow, let's see, what else do we need to do? We need to Oh, right, because we're doing these are wrong, right? So this is this is so wrong. Okay, so let's open this. We'll come here. We'll grab the we'll grab this one. There's the rear left. What we want here is the front mesh. Wait. Do I not have a rear wheel anymore? Like at all? Did I override my I did. I overrid my front wheel. Oh. We'll have to fix that tomorrow. In the meantime, we need to do this rename system here. This is actually the rear right wheel, which means this one is the rear left wheel, which means this one is probably the front right wheel. And this one would be the front left wheel. This one here is, again, going to be the rear right. Rear right. Rear left. Front right. Yeah, and front left. There we go. Then we come back to here and we see that the rear, this is the rear left wheel. This is not steerable. This is not steerable. This one's steerable. This one's steerable. Then this is supposed to be the front right, and this is supposed to be the front left, and this is supposed to be the rear right. Oops, rear right, and this is supposed to be the rear left. Now, when we drive, oh, now things, now we need to invert back. Yeah. Okay, so this, we can just go like this. This is left. I want this to be, this is left. We want this to be right. This is D. This is supposed to now be A. This is the right arrow. It's supposed to be the left arrow. It's supposed to be, we've got the left stick down. What? No. Left stick left. Left stick right. Left stick left. There we go. Left arrow. Sorry, give me a second here. I'm definitely getting this stuff mixed up here. Okay, that's correct. Let's make sure that the, yeah, that's correct. Okay. Let's make sure that this works. That's correct. Okay, that's correct. That's correct. That's correct. Beautiful. Okay. We now have things actually working. And I've been fighting with this all day, and I need a break. We're at about 7 hours of fighting, so I'm gonna take a break at 7 hours. And call about 7 hours and call it. We will pick this back up tomorrow, and we will get the steering actually visible, and fix the wheel locations, and hopefully actually get the wheels rotating and whatnot. So I think that's mostly done, and then we can move on to ragdolls. But it looks like we're probably going to get into ragdolls before the end of the week. Yeah. All right. Thank you to everybody who showed up, and I will catch you all later. I got some stuff I got to take care of outside of this. Anyways, ta-ta for now.